Okay, hello everyone, and welcome to day one of Microsoft Power BI Data Analyst Bootcamp. I am Andrew Ehrig with O'Reilly Media, and I will be your facilitator for today's session. Our instructor for today's course is Nicola Eilick. Quick reminder of a couple best practices before we begin. We do have the attendee chat in the widget tray towards the bottom of your screen, so if you have a question or comment at any time, you can submit it there. If you have a specific question relating to the topic, we do encourage everyone to submit those through the Q&A widget. But I would like to remind everyone to refrain from putting any personal information into the chat, anything like your email address or phone number, just because that chat window will be included in the recording of this webinar, and that recording should post and become available about 24 to 48 hours after the live session ends. Also, a reminder for those of you who are subject to regulated status, the chat feature should not be used. The audience may include customers, vendors, or competitors of you or your employer. If you choose to take advantage of the interactive features available in this training, and we hope that you will, you are responsible for any information you choose to share. So, without any further delay, I will turn things over to Nicola, and we can begin.
Thanks, Andrew. Hi, everyone. Good morning, good afternoon, good evening, depending from which part of the planet you are joining our bootcamp. And welcome to this two-day bootcamp called Microsoft Power BI Data Analyst Bootcamp, which is tailored specifically to get you ready for taking and passing the PL-300 exam and becoming a certified Power BI data analyst. As I like to say, there are a lot of people coming and joining this training who maybe already passed PL-300, or maybe they don't plan to take PL-300. But what I like to say is that as a side effect of this training, you will learn a lot about Power BI, if that may be called side effect at all. But generally speaking, we cover most of the topics relevant to all Power BI professionals, and all of the topics, so every single topic that is covered in the PL-300 exam. Again, I will just repeat to get the most out of this training. As Andrew mentioned, we have two options here to start the interaction and engage throughout the bootcamp. The first one is Q&A widget. So if you have any burning question or you need any clarification, please use Q&A widget, because in that case, I can guarantee 100% that I will take all of your questions. I can't guarantee that I will provide the answer, because it may happen that I don't know the answer, but I'll do my best. So use Q&A to ask your questions. You can, of course, ask your questions in attendee chat as well. But in that case, sometimes we have a lively discussion happening in the chat, and it may happen that by coincidence, I miss your question. So if you want your question to be addressed, use Q&A widget. Otherwise, use attendee chat for all your comments or your thoughts, and again, sharing the information that you want to share. So before we start, a brief introduction about myself. My name is Nicola. I work as a principal architect for iLink Digital. That's one of the largest Microsoft's implementation partners in the world. Mostly working with Power BI and Microsoft Fabric, working with Power BI since 2017. Also been recognized for the last 6 years as Microsoft MVP for both Microsoft Fabric and Microsoft Power BI. You can find me on web, data-mozart.com. That's the place where I'm blogging. I'm based in Salzburg in Austria. Currently also authoring one book for O'Reilly called Analytics Engineering with Microsoft Fabric and Power BI. But more on that tomorrow. Once we are done with all the topics relevant to PL-300, I'll share some available steps forward. So one of these steps is maybe if you consider continuing using Power BI in synergy with Fabric, this book may be a good starting point. I also co-authored the book Fundamentals of Microsoft Fabric together with Ben Weissman, also for O'Reilly, privately, father of 2 kids, and through football and Barca fun, as you can conclude looking at this photo here. What I like to do at the very beginning, since I introduced myself and I mentioned that I'm based in Salzburg, I like to ask participants to share their location. So no personal data, please. As Andrew mentioned, the chat is being shared with the recording. So just your location, because I'm always fascinated that we have people from all the meridians, all the parts of this planet. So we have people usually from Australia, India, Colombia, Europe, of course. So if you want to share in the attendee chat, you can share your location. So just as an icebreaker for the beginning. Okay, we have India, Bangalore, UK. So good afternoon, UK. Good afternoon, India. I think it's still afternoon, or maybe early evening on your side. Minneapolis. Good morning, Minneapolis. Oh, Lodz, Poland. Bratislava, Slovakia, Indiana. So as I said, like usual, we have people coming from all the corners of our beautiful planet. So yeah, thanks everyone for sharing your location. Surat, Chennai, India. Okay, awesome. Oh, we have a couple of people from Chennai. That's nice. That's nice. Thanks everyone for sharing. So yeah, let's proceed. Let's introduce the plan for upcoming 2 days. So what we are going to cover today and tomorrow. So for today, in the next approximately 5 hours, we'll see how it goes with timings and so on. Well, after this introduction, obviously, we will start with topics tested in PL-300 exam. The first big major topic is preparing and modeling the data. So we will discuss how to get your data into Power BI, how to perform basic and not so basic data cleaning operations using Power Query built-in tool inside Power BI, how to perform some data transformations and data loading process, design a data model, one of the key topics that is included in this PL-300 exam, enhance your data model with DAX calculations, optimize model performance, and last but not least, there will be a hands-on lab for you to practice. So usually we plan for this in like last 30-40 minutes of day one. We plan for hands-on lab. So I'll share all the details, and then you work on your own. I'll be there to support you, to help you. If you don't complete the lab before the bootcamp ends, of course you get the access. You'll see it's hosted on the web, so you can access labs afterwards and practice at your own pace. But be ready to get your hands dirty with Power BI. That's the main goal of this training, to get you ready for the real work with the tool. And then for tomorrow, again, we will come to revisit this tomorrow, but just to give you a brief overview of what should you expect tomorrow. So visualizing, analyzing data, first creating reports. Then once we create these reports, we will try to enhance them using various techniques and capabilities of Power BI. Identify different patterns and trends in our data, create and manage workspaces and assets, secure and govern Power BI items, and by the end of tomorrow's day, beside, again, one hands-on lab, we will also have a quiz. That's usually the most interesting part for most of the participants in these trainings. Why? Because we have some fun, and along the way, we also reinforce some key concepts that we learned throughout the training. So I encourage you to stay by the end of day 2 tomorrow and take part in this, as I like to call it, grande quiz. This will also, for all of you who are considering taking PL-300 exam, this will give you, let's say, a feeling what to expect in the real exam. So yeah, learning objectives, I'll just briefly walk through it, because you get this presentation anyway yourself. So the main goal, as I said, is to get you ready for the exam itself and to help you master these topics that are required to obtain the certificate. But also we have a goal to enable you or empower you to use Power BI in your day-to-day job. So it's not just about passing the exam. That's a nice bonus, but it's also learning how to use tool in some real life scenarios. Okay, so before we proceed, I have one question for you. What is your experience with Microsoft Power BI? I hope you at least heard about it. I hope we don't have anyone who will take answer A, what is Power BI? But even if we have someone, don't worry, we will explain this in the opening part of the training. So what is your experience with Microsoft Power BI? Let's wait for maybe 20 more seconds to give everyone a chance to respond. Okay, I see one response in the chat. I work with it, currently aiming to take the PL-300 exam. Awesome, awesome, amazing. I sincerely believe that this bootcamp will get you ready to pass the exam. Okay, 10 more seconds before we check results. Okay, let's see. We have some people who are not aware what Power BI is, but again, don't worry. That's how we start each of these trainings, to get everyone on the same page before we dive into, let's say, more intermediate to advanced topics. Most of you are somewhere in the middle here. Heard some people talking about it, but never tried it myself or created a few reports. That's a great starting point for this training. We also have people who can't start their day without coffee and Power BI. That's awesome. So yeah, thanks everyone for taking time to respond in the poll. And now we are officially ready to kick off our day one. And at the very beginning, let's first introduce the role of a data analyst. So as a data analyst, what are the responsibilities or tasks that you need to take care of once you start working with Power BI as a data analyst? So this is one of the several critical roles in the organization, which helps to uncover and make sense of information to keep the company balanced and to operate efficiently. So there are at least 5 key areas that you will engage in during the data analysis process. So let's examine these 5 areas. The first one is prepare. That means that as a data analyst, you'll probably spend most of your time split between the prepare and model tasks. Bad or incorrect data can have a major impact, as you will see throughout this training, which may produce invalid reports, loss of trust, and can negatively affect business decisions, which then lead to loss in revenue, negative business impact, and many more. The next phase is model. So once the data is in proper state, it's ready to be modeled. Data modeling is the process of determining how your tables are related to each other, and this is done by defining and creating relationships between the tables. From there, you can enhance the model by defining various KPIs, metrics, and adding custom calculations to enrich your data. The visualize task is where you get to bring your data to life. This means the goal of this task is to ultimately solve business problems. A well-designed report, as you will learn, should tell a compelling and impactful story about the data, enabling business decision makers to quickly gain needed insights. Using appropriate visualizations, interactions between these visualizations, an effective report basically guides the reader through the content quickly and efficiently, allowing reader to follow a narrative into the data. Analyze task is the important step of understanding and interpreting the information that is displayed in the report itself. And in your role as a data analyst, you should understand the analytical capabilities of Power BI and use those capabilities to find specific insights. And finally, manage. There are many components in Power BI, including reports, semantic models, workspaces, dashboards, and so on. And as a data analyst, you are responsible for the management of these Power BI items, which includes sharing and distribution of items like reports or dashboards, and ensuring that Power BI items are secure. So these are all the topics that are included, or all the tasks that are expected from Power BI data analyst. Before we proceed and talk about how to identify and connect to a data source, just as a brief introduction, Power BI is a business intelligence tool developed by Microsoft. It's offered as a software as a service solution, which means that Microsoft takes care of the infrastructure and everything else. You log in through the web URL and you start building and using Power BI reports. Power BI ecosystem consists of two main components: Power BI Desktop and Power BI Service. Power BI Desktop is a free application that you can download on your PC, unless you are using Mac. In that case, you can't download Power BI Desktop. You need to use a web user interface for report development. But if you are on a Windows machine, you download Power BI Desktop as a free tool, and Power BI Desktop is used for authoring, for creating Power BI reports. Once the report is ready, you publish it to Power BI Service. Think of Power BI Service as a cloud container managed by Microsoft, where within your organization you can share reports, dashboards, and other Power BI items with your colleagues. So it's a central place in the cloud where you publish Power BI content, and this content can then be consumed by other users as well. Okay, so let's talk about identifying and connecting to a data source. That's the first topic for today. When we are creating Power BI report, chances are that the data will come from more than one data source. Usually data is spread all over the place within the organization, and most commonly your task as a Power BI data analyst is to leverage all this data to create a unified overview and provide a meaningful insight from the data that might be stored across multiple locations and applications. Just to illustrate with a very basic scenario, let's say that all the sales data is stored in relational database management system, such as SQL Server, for example. Next, your HR data might be extracted from Excel files. Finally, let's imagine that our sales goals are defined in the SharePoint list. Now, what Power BI allows you to do, it allows you to connect to all these disparate data sources and combine data into a unified model, which will then serve as a blueprint for creating Power BI reports. Not only that, Power BI empowers you to apply various transformations to the data by leveraging a built-in feature called Power Query, which we will examine in more detail in one of the next parts of our bootcamp. So from a high-level point of view, this is what Power BI allows you to do, to combine data coming from multiple disparate data sources into a unified model. Now, shared versus local semantic model. Understanding this difference is one of the biggest points of confusion for many new Power BI practitioners. So in this part, we will introduce the key characteristics of both local and shared semantic models and explain potential use cases for each of these. Let's first examine the local semantic model. Once you connect to a data source or data sources, like I showed you in one of the previous slides, and you bring this data into Power BI Desktop, you are creating a local semantic model. This model may consist of data from one or multiple disparate data sources, but from the pure Power BI Desktop point of view, all the data you bring from, let's say, an Excel file, SharePoint list, and a SQL Server database is considered a unified semantic model, and it's also considered a local semantic model. It's local to the Power BI Desktop instance that we are using to create this model. Once we are done with building a local semantic model and we publish it to the Power BI service, it can be shared with others, and we are then talking about a shared semantic model. As already mentioned, shared semantic model is stored in the Power BI service, and from there, anyone with a proper set of permissions can access this semantic model by establishing a live connection from Power BI Desktop, which I will show you in a demo in a couple of minutes. This concept of the shared semantic model is extremely important for two reasons. First, it enables a clear separation between the reports and the semantic layer, which is considered a recommended practice in a multi-user environment. Moreover, the concept of the shared semantic model enables the creation of so-called reusable Power BI assets. Now, let me try to illustrate this with a very basic example. Let's say that I've created a semantic model that contains a sales table with all the data about the sales. And let's imagine that this table already contains evaluated and conformed calculation logic for all of our sales KPIs. This semantic model also contains product and customer tables, which are usually included in most of the semantic models. Now, what happens when you need to create a new Power BI report? You'll go and bring all this data to Power BI again and again directly from the source. But wouldn't it be more convenient if you could somehow leverage the model that was already created? And this is where the concept of the shared models kicks in. It's also frequently referred to as a golden semantic model or golden data set, which can be used by multiple different users who can then build their own reports on top of this shared model. Finally, because this golden semantic model usually contains checked and conformed calculation logic, it can be additionally labeled as promoted or certified to enhance its usability for downstream consumption. Again, we will talk about promotion and certification of Power BI items in tomorrow's part of the training, but this is just to give you a quick heads up about this. Fine, let's move on to the next one, which is choosing the storage mode. And I can tell you from my personal experience that choosing the right storage mode in Power BI is one of the key decisions that you as a Power BI developer need to make. Why? Because storage mode defines how the data is being retrieved to the Power BI report, and it is defined on an individual table level. There are three main storage mode types in Power BI. So let's examine them. Let's start with the default one, which is called import mode. When you choose import storage mode, Power BI loads the data from the data source and keeps it in the instance of the analysis services database called VertiPack. VertiPack is a columnar in-memory database, which means that the data is stored in the RAM memory in the compressed format. Because the data is compressed and stored in memory, queries retrieving the data from import mode tables are very fast, and they provide the best possible performance you can get with Power BI. With import mode, we are creating a snapshot of the data at a specific point in time. Think of bringing the data from an Excel file, SharePoint list, or SQL database. So when you press that load button in Power BI creates a snapshot of the data in its own database, right? To be able to have the latest data from the source available inside Power BI, we need to refresh the data. We need to refresh the data inside Power BI. In simple words, to take another snapshot. As long as you don't take that another data snapshot, your Power BI reports will query the previous one. And this means if you loaded, let's say, 1,000 records of data at 10 a.m., and after that, let's say at 11 a.m., there are 200 new records which were inserted into your data source. Power BI doesn't have an idea about these 200 records until you refresh your Power BI semantic model. Now, the fair question would be, how often do I need to refresh my Power BI data? Unfortunately, there is no single correct answer because it really depends on your business reporting requirements. It can be once per hour, once per day, once per month, and so on. So this is a typical workflow with import mode. We have a set of tables stored in, let's say, SQL database. These are the tables on the left-hand side of this diagram. And then we import these tables into Power BI local database. This is the cube in the middle. Essentially, we are creating a copy of the source data in Power BI. From there, Power BI report queries, and we are talking about DAX queries, will be executed against this local copy of the data. The main benefit of the import mode, as already mentioned, is a blazing fast performance. That's the best you can get from Power BI. On the flip side, the most obvious downsides are data duplication, because we are basically creating redundant data in Power BI, as well as data latency, since we need to implement data refresh policies to keep Power BI data in sync with the data source. Now, to overcome these, let's say, challenges with import mode, Power BI introduced another storage mode option, and it is called DirectQuery. With DirectQuery, unlike with import mode, where Power BI literally stores the physical data, when you choose DirectQuery mode, data resides in its original source before, during, and after the query execution. This is of paramount importance because it implies that the data is retrieved from the source at the query time. So let's take a look again at the usual DirectQuery workflow. In this case, we are not copying any data into Power BI. Power BI stores only the metadata. That means table names, column names, data types, and so on. When using DirectQuery, DAX queries generated by Power BI report are translated on the fly into SQL language, and these SQL queries are then executed directly against the source database. Since we are not copying any data into Power BI, DirectQuery overcomes the limitations of import mode, namely data duplication and data latency. This means whenever Power BI triggers the query, the latest data from the source will be retrieved and displayed in the visual. However, the key challenge with DirectQuery is performance, which is, I'm sure everyone who ever tried to use DirectQuery will agree with me that performance is, let's say, significantly worse than when using import mode. Let's put it that way. And then we have a third option, third storage mode, which is called dual, which is a combination of previous two, combination of import and DirectQuery storage modes. When you set the table storage mode to dual, I see someone can't hear me. Can others confirm that the audio is coming from my side? Oh, I see. So Andrew says, yeah, usually browser refresh helps. I'm sorry for the inconvenience. Okay, but thanks for letting us know. So as I said, with dual storage mode, Power BI creates two copies of the same table. One is cached as an import mode table, whereas the other one is stored as a DirectQuery version. And dual storage mode is commonly used in composite model scenarios when setting dimension tables storage mode to dual overcomes the limitations of limited relationships. But more on that later when we start investigating and exploring models, semantic models and building models. Composite model is one of these variations. So then we will talk in more detail about the dual storage mode. So that's the main use case for dual storage mode. So to clarify when you should use each of the storage modes, and this is super important for PL-300, understanding questions from PL-300 exam, import mode should be your default choice. And you should go this way whenever possible because it provides the best possible performance and supports all DAX functions. On the flip side, whenever you have real-time requirements, for real-time reporting requirements, or your data is simply too large to store it inside Power BI's database in import mode, you should choose DirectQuery storage mode. Dual, again, comes in those scenarios when you are creating composite models. Thanks everyone for confirming. Let's then move on to our next topic, which is parameters. Parameters are a well-known concept in many programming languages. In Power BI, parameters can be used to enhance reusability. So that's the first goal of using parameters. This means you can define a parameter, provide a value, store it once, and then reuse it whenever necessary. Additionally, parameters also enable flexibility because they allow for changing the query output in a dynamic way. Some of the most common use cases for parameters in Power BI can be first transformation step argument. You may implement parameter as part of Power Query transformation steps. Then also custom function argument. When you create custom function in Power Query, parameters can be used to dynamically change the function output. And finally, for incremental refresh, this is a very specific use case, which relies on two parameters with reserved names, range start and range end. Once again, we are examining incremental refresh in depth tomorrow. So we'll talk more about this specific range start and range end parameters when we reach that stage of the bootcamp. Okay, I talked a lot. It's time for a demo and to see some of these capabilities and action functions in action. So I'll show you how to connect to various data sources from Power BI, how to change data source settings, how to connect to a shared model, and how to set the storage mode. So first things first, let me share my screen. And since I got a feedback that you can see my screen much better when I go off the camera, I'll do exactly that. So I hope you have more space for the screen share. I'm currently in Power BI desktop. So just a brief introduction for those of you who never saw Power BI. This is Power BI desktop. This is, let's say, the initial page of the Power BI desktop tool. And it reminds of other Microsoft Office products like Word or PowerPoint or Excel. There is a ribbon on the top, different tabs that you can use. On the right-hand side, we have filters panel. More on that when we talk about filtering data in the reports. Visualizations panel, where we can pick between various visualization types and then configure them. And data panel, where we have all the data that can be used to create report. On the left-hand side, let me zoom this a little bit. We have 5 different views in Power BI desktop. The default one, the one that I'm using right now, is called report view. That's the one on the top. Then we have a table view. This is the one below. This one shows the data similar to what you see in Excel, for example. We have a model view where you can see all the tables and relationships between them. We are going to use model view extensively in the part when we start building our semantic model. We have a DAX query view that we are exploring tomorrow. And we have the latest addition, which is called TMDL view, which is helpful for managing semantic model properties. This is still not part of PL-300, so I will not specifically cover TMDL view, but if you have any specific questions about it, just let me know. Okay, so let's see how to connect to data sources. The starting point, whenever you launch your Power BI desktop on your PC, and first thing you need to do is to bring some data into Power BI, right? Because you can't build a report or model without data. So the data can be accessed from the top ribbon, this part here. Some of the most commonly used data sources are already included in the ribbon itself, like Excel, OneLake catalog. So this is for Microsoft Fabric as a data source. SQL Server, you can manually enter the data. Dataverse, to be honest, I'm not sure why this is included by default in the ribbon, but that's how it is. And of course, recent sources. So those are the sources that you've been using recently. But if you don't see your data source listed in the ribbon, you can click on Get Data, and then again see common data sources listed in this drop-down menu. Or if you click on more, then you will see the list of all the data sources that Power BI supports. This is a very long list, and obviously I'm not sure that you are going to use more than 20%, in best case, more than 20% of all these data sources. But what is a great thing about Power BI is that allows you to connect to a whole range of different data sources out of the box. So all of these are built-in connectors. Depending on where your data lives, you can leverage these connectors to connect and bring this data into Power BI. As you can see while I'm scrolling, there are most of cloud databases, file systems, Azure services, and so on that you can use as a data source for Power BI. So under Get Data, you connect to various data sources. Depending on the data source itself, the connection details will be different. That means that, for example, if you are connecting to a SQL Server database, you need to provide a server name and optionally a database name. If you are connecting to Excel file, you need to provide the location of the Excel file. So depending on the source itself, these options here in the dialog window will be different. So once you connect to a data source, you can change the data source settings. Under transform data, so I went here and clicked on this small arrow, there is the option data source settings. If I click on data source settings, I can choose between settings for the current file. You see that I have 5 different data sources in my current Power BI file, and those are 4 files, 3 CSVs, and 1 Excel file. And I also use SQL Server local instance of my SQL Server database. I can click on a particular data source, change this source, edit its permissions, clear permissions, and so on. Under global permissions, you can access all the data sources that you ever accessed from the Power BI. So that means that, as you can see here, I have all kinds of different data sources that I've been using. So under global permissions, you can access all of these data sources potentially, and make them if necessary, make changes to these data sources. So this is how you change the data source settings. How do you connect to a shared model? So let's say that I created a model that contains already validated data by someone from our business department. And let's say that I have some calculations that are already approved, and they can be useful for other report creators in our organization. So instead of loading all this data over and over again, you see I have more than 10 different tables that are included in this Power BI model. Instead of loading them over and over again, what I can do, I can publish this report to Power BI service. And then, so if I click publish and then click, I don't want to save, but nevertheless, let's connect to another one. So I'll open a new instance of the report. There you go. And if I now click on Get Data, I can choose Power BI Semantic Models option. This will allow me to connect to a Power BI model that has already been created by someone else. So for example, I can connect to this one, enhance reports for usability, whatever, and click Connect. So I'm now connecting to a shared Power BI model. And as you can see, this model already contains tables. So I don't need to go and load this data for myself in my Power BI report. I can directly connect to it. And from here, I can build my report on top of it. So I can create, for example, a very simple table that calculates total sales amount per product color. Again, don't pay too much attention on this. This is just to show you how you can leverage the existing semantic model and connect to it and build your own report on top of this shared semantic model. I'll now close this solution and go back to my solution. Here we are talking about the local model. So everything that I imported inside Power BI, so all of these tables that you can see here, this is part of the local model in Power BI. And everything that I built here, it's built on top of this local model. How do you set the storage mode? This is done from the model view. So if you go to model view, and then you see all the tables in our semantic model, don't pay too much attention right now on it. We'll talk about building model and relationships later in this bootcamp. But what I wanted to show you is how you can change the storage mode option. In this case, I can't do that because all of my tables are currently import mode. But if you click on the table and then go to advanced here, you will see that it says storage mode import. It's grayed out because you can't switch from import mode to DirectQuery, but you can do it other way around. So if I connect again to my SQL Server, and let's connect to the same database. But now instead of import, I will choose DirectQuery. Okay, click OK. Now Power BI is connecting to the local instance of my SQL Server. Here are the tables. So for example, we have dim currency here as an import mode table. So I'll again load dim currency, so the same table, but now as a DirectQuery table. Power BI warns me because I'm combining data from different source groups. So this is our dim currency. What I want to do is to move it close to this one so we can compare them. So now I have two instances of dim currency, same table, right? Same data, but this one has a blue line on the top. This means that the storage mode is DirectQuery, and if you hover over a table, it says storage mode DirectQuery. This one, when you hover over, it says storage mode import. For this dim currency table, now under advanced, you see that storage mode is available, so I can change it from DirectQuery to either dual or import. If you choose to load this as an import mode table to change the storage mode, it's irreversible operation. And that's what Power BI tells us here. Be aware that if you move from DirectQuery to import, there is no way back. Okay? So in this case, I will cancel this. Just wanted to show you one more thing, what we mentioned, as a difference between the import storage mode and DirectQuery storage mode. So if I go to a table view and I find my dim currency import mode table, data is here. You see, all the physical values from this table are displayed inside Power BI. If I click on DirectQuery version of the same table, there is no data. Remember what I told you. With DirectQuery, Power BI stores metadata only. So we see the column names, column data types, and that's it. We don't see physical data because physical data is not loaded into Power BI. When user interacts with the report, these queries will be executed directly against the data source system. In this case, it's SQL database. And that's the difference between DirectQuery and import mode. With import mode, we physically load the data into Power BI. With DirectQuery, we don't physically load the data. Okay, any questions before we proceed? I don't see any new questions in the chat or QA. Okay, then let's move on. We have a lot of ground to cover. So let's talk about profiling and cleaning the data. One of the greatest challenges when creating business reports is to achieve the highest possible level of data quality. So data profiling is the first and the most important step in the process of creating accurate and reliable Power BI reports. But what is data profiling in the first place? Let's first try to demystify this. I like the definition coined by Ralph Kimball. Maybe some of you heard about him. He's considered basically the father of dimensional modeling. Kimball talks about or identifies data profiling as a systematic upfront analysis of the data source content. So let me break this definition down into a few key areas. Upfront means that you have to know your data before you start working with it. Systematic assumes that you need to check all the aspects of your data, from checking the memory footprint, column cardinality, data quality, and so on. And finally, you should perform data profiling on the source data. Simply put, if the data is of bad quality in the source itself, you can't expect that reports will display accurate numbers. There is a saying, garbage in, garbage out, and keep this always in mind. Luckily, Power BI provides a range of built-in features to enable data profiling. The core work is done within Power Query Editor, which I will show in more detail in the next demo. So Power Query enables us to do a quick and easy data profiling by leveraging 3 out-of-the-box features. And for all of you who are considering taking PL-300 exam, please try to memorize what each of these 3 options provide within the Power Query Editor. First is column quality, which displays percentages of valid versus error versus empty records. In a perfect world, 100% of data will be valid, but yeah, that's not always the case in reality. Column distribution displays the data distribution within the column as well as the number of distinct and unique values. These two are not the same. Distinct values include duplicates and nulls, while unique values are values that occur only once in that particular column. And we have column profile, which displays a more, let's say, in-depth overview of the column, including the count of records and if there were errors while importing the data in the specific column. You can here also check the number of empty rows, minimum and maximum value within the column, and so on. That is especially useful when you profile a numeric column, since you can quickly spot and identify any possible outliers. This is about profiling. There is a question, sorry I missed that. Can we use NoSQL as data source as well? Yes, absolutely you can. So there are many NoSQL databases that are supported, like Cosmos DB or MongoDB, that you can connect out of the box from Power BI Desktop. So yes, you absolutely can. Okay, I don't see any other questions. So let's talk about resolving data import errors. As we said, in an ideal world, all our data is clean and shaped, and the process of bringing this data into Power BI is like a smooth sailing. But unfortunately, the reality is far from this fairy tale, and we usually need to deal with different challenges when preparing the data for our reports. Finding the root cause of the error might sometimes be a daunting and tedious task. The reason is simple. Power BI usually imports data from numerous sources, and each source might produce dozens of different error messages. Also, there are additional components involved in this process, such as hard drives, networks, software services, that can also trigger their own errors. So here I will narrow down and briefly examine some of the most common data import errors. Please keep in mind that this is not an exhaustive list. There can be more than these errors that you face, but these are the most common ones. First is query timeout, which means that resources are being constrained by concurrent users trying to access the same data. Couldn't find data formatted as a table. This error is caused when Power BI expects to find data formatted as an Excel table, but this is not the case. Could not find file. So this one is one of the most common errors. If the file changed its location, or if the permissions to access the file have been changed, Power BI will throw this error. Data type errors, again, very common error. This error refers to problems with interpreting the data type in Power BI. A very basic example, there is a numeric column in your Power BI semantic model, and all of a sudden there is a value that is non-numeric in your data source. So Power BI will throw an error for that particular record that it can't be converted to numeric value or something like that. So data type errors are very, very common in Power BI. Now, let's move on and show some of these in action. Again, it's nice when you hear me talk, but I think it's way more useful when we demonstrate this directly in Power BI. So let me again share my screen and go off the camera. Okay, let's go back to home of our report view. So for these things, to show these things, I will use Power Query Editor. For those of you who are not aware, Power Query Editor is a built-in tool inside Power BI Desktop that allows you to perform a bunch of different data transformation operations. And the greatest thing about, or let's say one of the greatest things about Power Query Editor is that all of these transformations you can perform without writing a single line of code, which is great for many Power BI professionals who are coming from, let's say, business background. They are not proficient with writing any programming languages. So Power Query allows them to perform really complex data transformations and data manipulation operations without writing a single line of code. All of this using graphical user interface. Power Query Editor can be accessed from Power BI Desktop. If you click on Transform Data, it will open a new window, basically, new user interface, and this is Power Query Editor. Again, just a brief introduction. On the left-hand side, you will see all the queries that are part of this particular Power BI semantic model. In the middle, you see the details for that selected query. So if I click on dim currency, I will see the details for the dim currency table. If I click on dim customer, it will show me the details for the dim customer table. So columns, column names, data types. Here, data type can be seen in the left corner of the column name. 1, 2, 3 means this is the whole number data type, numeric value. ABC means this is text. Let's see if we have something else here. We have a binary data type, so yes, no. We have date, and so on and so on. So you can find data types here in the left-hand side of the column. On the right-hand side, you see the transformation steps applied to a specific table or specific query. What is another great thing about Power Query Editor is that all the transformation steps that you applied, once you save your Power BI file, every time you refresh your data, you don't need to perform all these transformation steps all over again. Power BI records or remembers all of these transformation steps, and it will automatically apply them to the data source based on what you define, what you configure here in the applied steps part. So this part here, whatever you do with your data, and we will do a lot of things in next couple of minutes, everything is saved under applied steps. Okay, I promise you that we are going to examine data profiling options first. So data profiling options can be accessed from the View tab. If you go to the View tab on the top, and then those are these three options that we previously mentioned. So column quality, let's first turn on column quality. Once I do that, it will show me for each column the percentage of valid, error, and empty records. Since my data is coming from a SQL Server database, it's already cleaned, and I don't have any errors or any empty values. But in real life, you can quickly find if there are any issues with the data quality in particular table or column. So column quality shows you this in a column header. It shows you the percentage of valid, error, and empty values. Again, I'm repeating this multiple times because this is tested in PL-300. I'll now turn this off and then go to column profile. Column profile shows you for the selected column, it shows you detailed statistics, like how many records are there. Currently, there are 1,000 records because profiling is based on, by default, on top 1,000 rows. You can change this if I click column profiling based on the entire data set. Let's do that. Power BI will now load the entire data set. And as you can see, we have 60,000 records in this table. It will show me how many distinct values we have and how many unique values we have. What are the minimum and maximum values in this column? This is text column, so based on the column data type, these column statistics may vary. So if I go here to say, let's take something which is numeric value, like, for example, unit price. So now it makes sense because it shows you what is the minimum maximum value, but it also shows you the averages and standard deviation. Why is this useful? So I'll give you a very basic example. Let's say that I'm now profiling a customer table, and let's say I think there is a column called number of kids or something like that. Let's try total children. So imagine that someone by mistake entered value 99 or -1. Maybe the value was unknown, so someone entered some dummy value like 99. If you don't do data profiling, this value will end up in your report, and your averages will be affected by that. I mean, in theory, someone can have 99 kids, but yeah, I would say it's very low probability. But anyway, the idea here with data profiling is to quickly identify any possible outliers and investigate what is the problem, or maybe there is not a problem, but investigate if this is really an outlier or if you have a data quality issue. So data profiling allows you to do that very quickly and easily directly from Power Query Editor. And finally, we have the option called column distribution, this one, which shows here in the column header, it shows number of distinct values and number of unique values, as well as how many of them exist inside the data set. So you can see that the maximum value is someone has 6 kids, but there is less than 1% of values in this column with 6 kids. Most of them are probably somewhere between, I don't know, 0 and 2 or something like that. But the idea behind these tools is to help you quickly identify any possible data quality issues that you might have in your table. The next thing I want to show you is how to resolve data inconsistencies. So for this, I'll use my DIM reseller table. And inside DIM reseller table, we have a business type column. That looks more or less okay when you take a look from a high level. But if I expand and click on this arrow to see all the unique values that exist inside this column, you can see that we have where and then blank space house and warehouse. Essentially, this is the same thing, but you have a data consistency problem. Why? Because if you load the data like this in Power BI and you try to visualize the data based on the business type, you will get a problem because numbers will be broken down based on the where blank house and warehouse. Whereas from business point of view, this is the same thing. So those are the things that you need to resolve in advance. How can we resolve this? Simply right click on the column, replace values. So I'll find a value called where blank space house and then replace this with a warehouse. Please pay attention what happens here. So in this area, once I click OK, there is a new transformation step, replaced value. First things first, let's check if we really got rid of our data inconsistency. So I now expand this and there are no 4 distinct values. Now we have 3 distinct values where warehouse is basically used for all the warehouses, right? And another thing, we have this transformation step saved. So every time I click refresh, when new data comes, this transformation step will be automatically applied. As you saw, I didn't write a single line of code. This transformation was performed from the graphical user interface, but in the back end, what Power Query Editor is doing, it's creating a formula for me. So to replace this var blank house with var house, there is a special function called table.replaceValue. The language, the programming language that you are seeing here is called M. So M is the programming language for data transformations and data manipulations inside Power Query. So this is the code automatically generated by Power BI for me. If you want more control, or if you are a code first person, you can, of course, write all of these transformations by using M programming language. Clicking on Advanced Editor will allow you to see the entire code, the entire transformation code for this particular table. So source step, and then schema and the table name, and finally the transformation step that we've applied from graphical user interface. I can now, of course, make some changes here if I want. Of course, I don't want to do that, but if you want to handwrite your M code, you can absolutely do that. So now we resolve data inconsistency. What happens if here I have two CSV files, and what happens if the location of the CSV file changed? So I'll take this 2019. So here I am, just to show you what I'm doing. So I'll put this outside of my data files folder. And what happens here now, when I go here and click on source, there is an error. And the error says data source not found. So Power BI couldn't find the file in the original location where we shared it. So this happens a lot in real life, because people are loading data from their PCs, and location of these source files may change. Or if you connect to, I don't know, shared location on your SharePoint server, sometimes people are moving files around, changing folders, and so on. So this is one of the most common errors that can be thrown. So in this case, Power BI searched for the CSV file inside this folder, but there is no file with this name inside of that folder. So that's why we see the error. So we need to fix this error. Otherwise, we can't use this table. So if I go back, and let me quickly move this file back to its original location. So now if I go back and refresh it, now it will show me the original one. Click OK, and it should be solved now. Let me see. Maybe I need to just to reconfirm. Click OK, click OK. And refresh preview. Now it works. So be aware of these small, let's say, I like to call them paper cut problems, paper cut issues. So under the source, you can always change the original source for your file. Anyway, for every transformation step that you make, like I did here, for example, what we did in DIM reseller, if I'm not happy, or if I want to change something, you can always click on this small gear icon, and then open it again, and then change the configuration that you previously defined. Most of them have also advanced options and so on. Okay, any questions? I don't see any new questions. Good, then let's move on. Let's move on to our next topic, which is transform and load the data. So before we jump into explaining various topics here in more depth, I want you to remember that when it comes to data transformation in Power BI, Power Query is your best friend, really. And in the following sections, I think you will understand why Power Query is one of the most important components of entire Power BI ecosystem. Let's first talk about data types. I already mentioned how you can find the data type of the specific column. So in the left corner of the column name, you can see the data type for that particular column. Handling data types it's an evergreen topic, let's be honest, and it's not something exclusively related to Power BI, and its semantic models, on the opposite, I would say, each and every data solution's efficiency heavily relies on using proper data types, and Power BI is no exception. So in this part, we're going to learn the most common data types in Power BI and in which scenarios to use a specific data type. When you connect to a data source, Power BI will analyze the sample of records and will try to automatically convert column data type to the most optimal type. Before I show you in a demo again how this looks in reality, let's first explore the frequently used data types. I'll separate them into three main groups. The first one is number types or numeric types. Here you can choose between three different options. Let's say that we need to store the number 47.0003852. To keep this exact same level of precision, you have to use decimal number data type, which stores the value with up to 15 digits of precision. If you are happy with only 4 decimal places, you may choose a fixed decimal number data type. Finally, if you don't care at all and if you don't need any precision after the decimal point, you can store the value as a whole number. It's slightly more complex with date-time types. In this case, the selection is more nuanced because you may want to store your date-time related data in 5 different ways, including the information about the time zone or even as duration in days, hours, minutes, and so on. Last but definitely not least, text type. Even though there is only a single text type in Power BI or Power Query, I want you to be aware of a few things here. The first is case sensitivity, which might look a little bit counterintuitive at first glance. Storage is case insensitive. This means when you load and store data in Power BI, it doesn't make any difference if you store, let's say, Argentina starting with a small letter A versus Argentina with capitalized A. But in Power Query itself is case sensitive. So if you compare Argentina with small a and Argentina with capital A, these two are not the same. Another curious case is related to leading and trailing spaces. While trailing spaces are automatically removed by Power Query, leading spaces stay as they are, unless you explicitly remove them using Power Query transformations. So again, if you do some comparisons based on text values, be aware of these nuances of how Power Query works behind the scenes. Choosing the appropriate date type is not only important in regards to how the data will be displayed in the report. Moreover, it has a huge impact on the size of the Power BI semantic model and its efficiency. Again, in one of our next modules, which is called Optimize Model Performance, we put more emphasis on understanding this semantic model size and how data types can affect data model size. Okay, the next topic is star schema. So again, I have a question for you. Do you know what star schema is? While we are waiting for your responses to arrive, I see the question in the chat, which says in the file 2019, let's say we have 200 records and we receive the latest file with 250 records, how the latest file will get updated. So if you're using import mode model, Power BI stores the local copy of the data at the moment when you click this load button. So assuming that this new file contains more records, you need to explicitly refresh the data inside Power BI. Once you click the refresh, if the file is of the same structure, so same column, same everything, it will simply load the new version with 250 records. It will overwrite the existing file. Assuming again that the file is has the same name, it's on the same location, and all the things that we discussed previously. And the file itself has the same structure with columns and everything else. I hope this answers your question. Let's wait maybe 20, 30 seconds more for everyone to respond. Ten more seconds. Okay, let's check results. Okay, most of you either haven't heard about star schema or heard about it but have no idea about how it's being used. No worries at all. Also, we have people who are familiar with the concept and already implemented it. Don't worry, for majority of you who answered, who picked option A or B, we are going to explain what star schema is and of course in which scenarios it makes sense to use it when it comes to Power BI. So talking about star schema, it's one of the core concepts that exist in data modeling. And for this particular training, and particularly for Power BI, we'll focus on understanding the concepts of dimensional modeling. Before we come up to explain why dimensional modeling is named like that, dimensional, let's first take a one step back and explain some history lessons. Approximately 30 years ago, I think it was 1996, a man called Ralph Kimball, I already mentioned him previously when we talked about data profiling. He and his team in Kimball Group, they published a book, Data Warehouse Toolkit, which is still considered the dimensional modeling Bible. And if you want a friendly advice, I know you didn't ask, but if you want a friendly advice, if you plan to work with Power BI seriously, I strongly encourage you to read this book. It's old, but it's gold. So the Data Warehouse Toolkit, that's the name of the book. In this book, Kimball introduced a completely new approach to modeling data for analytical workload. So if you find yourself surrounded by experienced data modelers, you'll probably hear them talking about stars and snowflakes. And don't worry, they haven't become astrologists or nature researchers all of a sudden. Star and snowflake schema are probably the most influential concepts in the world of dimensional modeling. So let's now try to explain the star schema. According to Kimball, each piece of data should be classified either as a dimension or as a fact. Dimension tables usually answer the question starting with W. Who, what, when, where, why. Who bought something? What did they buy? When did the transaction happen? And so on. So if we think of a dimension as a lookup table, a fact table is a table that stores the data about events, something that happened as a result of the business process. In most cases, but not always, these events are represented with numeric values. How many tickets did we sell? How much revenue did we make? And so on. So in a well-designed dimensional model, you should have a central table containing all the measurements and events. This is a fact table, surrounded by lookup tables, which we refer to as dimensions. The fact table and dimension tables are connected via relationships established between the primary key from the dimension table and the foreign key from the fact table. If you take a look at this illustration that you can see right now, you will understand why this data modeling design pattern is called star schema. It reminds of a star. And talking about star schema is a de facto standard for modeling data in enterprise data warehousing systems. Why? Because it enables efficient querying of huge amounts of data, fast aggregations, and intuitive data filtering. So those are fact table and dimension tables in our star schema model. Let's quickly reiterate the key benefits of building a star schema for business intelligence scenarios. The first one is user-friendly data navigation. As users, we often get it easier when thinking about the business process in terms of the subjects that are part of this process. Which event sold the most tickets in the second quarter of the last year? How many tickets were bought by female customers for the Champions League final game? Or which employee in the USA sold the most VIP tickets for Super Bowl in 2026? And many more, of course. That's the first reason. The second reason is flexibility. This is one of the key advantages of dimensional model. Did your customer change the address? Did your employee change position within the organization? No problem at all, as all these challenges can be easily handled within the model by using a technique called slowly changing dimension. The next one is consistency. Star schema allows for consistent analysis because no matter how many queries you run, the data will follow the same path every time and promptly generate consistent results. And finally, Power BI engine is optimized to work with the star schema model. If you don't trust me, there is the official star schema guidance on Microsoft Learn documentation. I will share the link there. It's full of wonderful explanations about dimensional modeling and star schema. So Power BI as a tool loves star schema. So to cut the story short, star schema should always be your default choice when designing and implementing Power BI semantic models. If you ever get a question in PL-300 that is related to building the most optimal and efficient semantic model for Power BI, the answer is definitely something related to star schema. So that's why it is important to understand this concept. Yeah, absolutely. There is a question which says, can you write the name of the book and the author in the chat? Absolutely. So the book is called The Data. Let me just type it quickly. Data Warehouse Toolkit, written by Ralph Kimball and Margie Ross. I think these two, I have it here. So maybe I can take a quick look. Yes, it is. So just to, maybe it's easier when you visualize it. Here is the book. So the Data Warehouse Toolkit, strongly suggested for everyone who plans to work with Power BI. This is still considered the Bible for building optimal semantic models. I think the latest edition is third edition from maybe 10 or 15 years ago, but it's still absolutely relevant. So don't pay attention to the published date. Okay, so let's move on. Let's talk about the difference between referencing or duplicating queries and the resulting impact that this decision may have in Power Query. One of the common points, let's say, of confusion in Power Query is what is the difference between the reference and duplicate query option. So let's try to explain both options and examine potential use cases for both. When you duplicate a query, it takes a copy of that query, including all of the applied steps. From there, all the changes you make to the duplicated version of the query will not affect the base query. So we can conclude that both original and duplicate queries coexist as completely independent queries. A common use case for this approach is when you want to test the impact of possible changes while still maintaining a copy of original steps. On the other hand, when you reference a query, it doesn't copy all the transformation steps from the base query. It will simply create a query with a single transformation step included, and that transformation step is essentially the end product, the end result of the base query. On top of that result, you may add additional steps to the referenced query. However, the key difference compared to the duplicate approach is with the referenced query, if you make any modifications to the base query, these will also affect the reference query. A common use case for reference query option is when you need to derive fact and dimension tables from a single flat table, as I will show you in a demo when we start talking about Power Query transformations. The next one is append versus merge. This is also something that happens a lot in real life scenarios. And in these scenarios, you'll often need to combine the data from multiple tables or multiple queries. Luckily, Power Query provides a convenient and straightforward solution to this challenge. Based on your specific requirements, you can choose between the append and merge operations. So let's briefly examine both of these options. In the first scenario, this is on the left-hand side, we have two tables of identical structure. The first table contains data for the year 2023, whereas the second table contains the data for the year 2024. Usually we want to combine this data together so it can be sliced and diced in a more intuitive way. In the second scenario, we have two tables of different structure, but they have a common column, product. Here the requirement is to include some columns from the product category table into the product table. With append transformation, we are basically adding rows to the existing table, thus making this table longer. On the flip side, with the merge transformation, we are adding columns to the existing table, making our table, original table, wider. Let me show you this. I'll show you this in a very basic example, but before we do that, so with append, we are adding rows to the existing table. With merge, we are adding columns to the existing table. This is the biggest difference. With the append, we make the table longer. With merge, we make the table wider. When it comes to merging query options, there are a couple of types of merge operations that you should keep in mind. And especially, again, this is 100% tested in PL-300, so make sure to memorize or understand how these different join operations in merge work. So I have a very basic example here, two tables, table A, table B, both containing the fruit column. So what happens if you select the left outer join option, where table A is the one on the left side of the join operation? Merge table will contain all the records from table A plus matching records from table B. So you see that the third record, banana and mango, they don't match, so we don't see mango displayed in our final result set. This is left outer join. Right outer join is the opposite. All records from table B will be included this time and only matching records from table A. With inner join, only matching records from both tables will be part of the merge table. And finally, with a full outer join, all possible combinations of records are included in the result. Again, understanding different join types in the merge transformation is of paramount importance, not just because of PL-300. Obviously, that's another reason, because I can tell you that it's 100% tested in the exam, but also for real life scenarios, because it can have an impact on the data accuracy. So make sure to understand each of these join options in a proper way. When it comes to column keys, keys in the columns, keys in the tables are defined on the columns that contain unique values. So whenever you have a unique identifier for a table record, we assign the key, we define this column as a key column. Inside dimension tables, we usually have unique values for each record. And in this case, we are talking about the primary key. Primary key is always unique. And these keys are useful for establishing relationships and performing join operations later for when you are doing merge. Another option to consider when you build your Power BI reports is, do you want to load all the data or just some particular columns? So there is an option to disable the data loading for particular queries in Power Query Editor. Once you disable this query or table inside Power Query, it will not be available in the report. I will show you this in a demo, I promise. So by default, everything is loaded into Power BI, but in many cases, you will have some intermediate, some helper tables or staging tables that you use to calculate something on top of it. And in those cases, you don't want these intermediate or staging tables to be available in the report itself for different reasons, not to confuse end users, not to produce unexpected or inaccurate results. So for these intermediate staging tables, you should disable their loading into Power BI, and they will not be available then for the end user. Okay, so the next planned thing is to showcase all of this in a demo, but since we are almost 90 minutes in, let's do a short break first to stretch our legs, refresh our brains a little bit, and then straight after the break, I'll show you these concepts, these capabilities inside Power BI. So let's take a 10-minute break, and I'll see you in approximately 10 minutes. Enjoy your time and see you soon. More breaks? Yes, of course. 2 additional breaks are planned. So yeah, I don't want to keep you all the time in front of your screen. So there will be enough time to stretch your legs and refresh your brains. As we talked and as I promised, let's do a couple of demos before we proceed. So I'll show you some common data transformations and how to implement them with Power Query, how to combine queries, how to work with parameters. Query folding we will leave for the semantic model optimization part. And then finally, how to implement a star schema with Power Query. So without any further talk, let me share my screen. And go off the camera. Okay, so let's first close this data profiling option. So some common data transformations in Power Query. Obviously, the things that I'm going to show you here is just a small subset of the transformations that are supported, but these are some of the things that you will perform probably in more than 80% of your real-life scenarios. So let's start with merging columns. I will go to the dim customer table, and as you can see, we currently have first name and last name as 2 separate columns. In many cases, your business users want to analyze or see the full name of the customer. So instead of doing this on a report level, we can create a new column, or basically merge the column that will contain both first name and last name combined. So I will, while selecting first name, I'll press Control key and then select last name column as well. Right click on it, and then there is the option merge columns. Once I click on merge columns transformation, you can define a separator. Currently it says none, but we want to include a blank space in between first name and last name. So I'll change this to space. As you can see, there are some predefined separators, but you can also define your own custom separator. So let's use space, and the new column will be called full name. Click OK. And now we have a column called full name, which does exactly what we wanted. But what we did right now, we merged existing columns into a new column. And when we did that, the original columns are gone. So they disappeared. this is not something that we want. We want to create a new column called full name, but also to preserve our original columns, first name and last name. So what I'm going to do, I will delete this transformation step here, clicking on this red sign. So again, we are back at our starting point, first name and last name. So whenever you want to add additional column to your data set, to your table, you will go to Add Column tab on the top. Once I click Add Column, I can create a custom column. And custom column, let's call it again full name. And the formula will be, so first name, and let's include a blank space. The ampersand is just a concatenation operator in M language. So first name and last name. Power Query will immediately warn you if you have any syntax issues. If everything looks fine from the syntax point of view, not logical point of view, but from the syntax point of view, you will get this green check mark and then you can proceed. Once I click OK, there is a new column called full name. And now we have our original columns, first name and last name preserved, and we have a new column called full name. The one thing that most people forget to do after this, after you create a custom column, Power BI will automatically apply any data type to this column, which is considered a bad practice. So the first step after you create a custom column should be to change the column data type from any to a proper data type. In this case, since we are talking about the text values, we can safely change the column type, data type to text, and then we can perform all the built-in functions for text. This is how you add a custom column. We can also add a conditional column. So let's say that you want to display in your report, you want to display or divide, let's say, all the customers that have car versus those that don't have, that don't own car. So there is a column called number cars owned. And for example, if I want to create a new column based on the value in this one, so I'm not merging anything, I want to introduce additional logic on top of this, on top of these values from number cars owned column. So what I can do, I can say I want to create a conditional column, and then new column, let's call it has car. So if number cars owned is less than 1, then I want to say, for example, yes, otherwise I want to say no. Of course, you can add multiple clauses and create a chain, or logical chain basically. So if it's less than 1, if it's greater than something, if it's, and so on and so on. In this case, let's keep it simple. So I'm just creating one condition. If the value in this column is less than 1, then, oh, it should be no. Sorry, my logic was incorrect. So if numbers of car owned is less than 1, then no. Otherwise, yes. Once I click OK, here is our column. So whenever the customer doesn't have car, we will have the value no. Otherwise, we will have yes. And again, since this is true false, we can, yeah, I can't change it to true false because I have text values. But this is another example of something that should be taken into account. So whole number, my bad, this is text, obviously yes, no. If you put 1 or 0, then you can use binary type or whole number, but since I'm using text values, then it needs to be text data type. Another recommended practice is to rename your transformation steps. So in this case, it's very simple because we have just a couple of transformation steps, so we can memorize what we did in which of these steps. But once your transformation pipeline in Power Query starts to grow, it becomes very complicated to figure out what each of these transformation steps is doing. So if you want to make any changes, it's really hard to find the proper transformation step. So what is a recommended practice? Rename step and say change type has car. Now, for example, or edit has car. Now you know what is done, what's been done in each of these transformation steps. This is a conditional column. There is also an option to create a column from examples. So let's use dim customer. I think there is something like salary or something like yearly income. Yeah. So yearly income, and then if I click column from examples, and then from selection, and then I can provide some examples here, and Power BI will then try to pull out all the values here. So inside of this column, I can say whenever someone has 90,000, I will put 90,000 to 100,000. So we are creating bins of 10,000 of yearly income, so we can then display the data in the report based on these bins. So let's see if this works. So once I click enter, it correctly recognized my logic. So it says range is between 90,000 and 100,000. This is between 60 and 70, 70 and 80, 80 and 90, and so on. If I'm happy with this, if I don't want to change, I can click OK. Of course, you can tweak this formula if necessary, but this is something that you can also leverage this column from examples. Another thing I want to show you is a very common use case. You get a data that looks something like this. Imagine that your data source is an Excel file, and you can find this structure within Excel file very, very often. And for Excel, this is quite fine, right? But for Power BI, this is awful. Basically, you can't create any type of reports on top of data that is structured like this, right? So we need to shape and transform our data set here to be able to perform some meaningful analysis. So, okay, let's go first and perform some transformations. So I'll go to home and then remove rows. Let's first remove blank rows, because as you can see, we have a couple of blank rows here, here, here. So we want to get rid of all these blank rows. So remove rows, remove blank rows. Now these blank rows are gone. Okay? This sales by category, this is just a title that exists in Excel, which is completely useless for Power BI. So I'll go and say remove top rows, and then number of rows, I want to remove just the first row here. So I'll remove the first row, it's gone. And finally, as you can see, we have column names displayed in the first row of this data set. So we want to use these year, month, sports, media, clothes, and so on as column names. So what I'm going to do, I will go to transform and then use first row as headers. Now, this looks much better already, but we are still not there. So now we have these column names properly displayed. We have proper data types. So whole number for numeric values, text for month, and number for year. Okay, so let's do the next thing. Inside the year column, we have the starting value for January. We have 2023, and then for January 2024. But all the other values are null, right? So we need to fill out these values. So I'll go to year, and then fill, and then down. What is going to happen basically is that it will, as it says, let me open this, hover over, it will fill down cell values to neighboring empty cells in the currently selected columns. So once I fill this down, you see now we have 2023 for all the months from 2023, and then whenever there is a next value which is non-null, it will start with this new value and fill down all the values. You can go obviously in the opposite direction as well, so you can fill up values if necessary. Okay, and then finally, since we have columns displayed, we have product categories displayed as columns, which is again not the proper structure for Power BI. The idea here is to have a separate column called product category, and then all the values for that particular category. So I will select year and month. So I click on year, and while pressing Control key, I pick month, and then right click, and then unpivot other columns. Now we change the structure of our table. And instead of attribute, let's call this category. And let's call this sales, for example. Now we have a properly shaped data for Power BI report. As you saw, I had to perform 1, 2, 3, 4, 5, 6, 7 different transformation steps to shape our data. And now I'm ready to load this data into Power BI. Let's talk about combining queries. So append and merge. Appending queries, I'll show you on this example with 2019 and 2020. So as you can see, inside the order date column, let's load everything. So we have dates starting from 1st of July 2019, and the last date is 31st of December 2019. In 2020, if I check, then dates start from 1st of January and ends on 31st of January. So the idea is to combine these two tables into one and allow end user to slice and dice data from the unified view of these two tables. So while selected 2019 and then append queries, so it's here under combine, append queries, I can choose to create a new query, basically, which will create a new table, or I can append new records to the existing query, to the one that I currently selected, which is 2019. And that's what I'm going to do. So append queries, and then I can choose either to append just 2 tables, or I can append more than 2 tables. In case I have 5 years here, I can select 3 or more tables and then append all of these tables in one run. So in this case, because we have just 2 tables, I will append 2020 and click OK. Nothing happens. At the first glance, everything looks the same, but let's check our order date. Load more. So the data still starts from 1st of July 2019, but now we also have records from 2020. Because this table is not just 2019 anymore, I'll rename it to 2019-2020. And since we have these records already in another table, these 2020 records, instead of loading this data twice and confusing our end users, I will right-click on this table and then disable the loading. Remember when I told you, for these helper intermediate tables, you should disable their loading into Power BI. Once I click disable loading, continue, the table name is written in italic font, and once I hit close and apply, this table will not be part of the model anymore. Just to prove that this is happening, once I click OK, look at this. We now have 2020 here and 2019. Once the data loading is done, 2020 is gone, and we have a unified table with 2019-2020. That's append, okay? Let's now see the merge operation. With merge, this is an example that we already discussed. We have one table with fruits, apple, orange, and banana, and another table with apple, orange, and mango. So if I go to table A and then select merge queries, again, you can create a new one or join columns to the existing selected table. So let's do that option, merge queries. So I'll select this column and table B merge this column. Now here from the drop-down menu, you can pick the join kind. And it immediately says this selection, the selection matches 2 of 3 rows from the first table. You can pick between left outer, right outer, full outer, inner join, left anti-join, and right anti-join. Don't stress too much about left anti and right anti-join. These are rarely used in real life. So focus on understanding these first 4. So with left outer join, once I expand this table, you see that, like I shown you in this slide, apple and orange are matching, banana and mango are not matching. Since we use left outer join with the table A as our first table, then it will show null for non-matching values. Right outer join will do exactly the opposite. Inner join, for example, so if I do, instead of left outer, and I do an inner join and click OK, it will show only matching records between 2 tables. Okay, so that's how merge works. It makes the table wider. Managing parameters. So parameters can be defined from here. Manage parameters. And then let's create a new parameter. Let's say instead of every time typing my server name and my database name, what I can do, I can say, for example, this will be my SQL server, and the value will be, for example, this is the name of my server. And let's create another one for database, and this will be the database name. And let's create, for example, for date. So start date. This will be date data type, and the value will be, for example, 2020 0101. Click OK. Now we have 3 parameters here. As you can see, those are parameters. So for example, let's say I want to bring data from SQL Server. Instead of writing the server name, what I can do, I can switch to parameter and then choose my SQL Server. Power BI will replace it with the value of the parameter. And for database, I can also switch and say my database. And now it will use these values to connect to the SQL database like I did in one of the previous cases. Parameters can also be used to filter the data. So what I did here, I created a start date parameter, and let's say I want to keep only records that are after 1st of January 2020. So I can go here to this small arrow, date filters, and then after. And then I can say keep rows where order date is after or equal to. And then instead of hard coding the date value, I can set my parameter and select start date, click OK, and it will contain only data starting from 1st of January 2020. So you can parameterize what is displayed in the data set based on parameters. You use them as filters. And finally, I want to show you how to create a star schema from the flat table. This is usually the case when you get the data coming from Excel spreadsheets or similar. For this, because we already have a star schema model in this file, what I'm going to do, I will create a new file. So let me first close and apply. So I'll go to File and then Blank Report. For this, I'm gonna use sample data provided out of the box inside Power BI. So use sample data, this one. So you can also replicate this on your own. And this is a very good exercise for creating a star schema, because the data that is provided as a sample data comes in a form of one big flat table that contains all the data. And that's usually not a good idea for Power BI. So just to show you what I'm talking about, this is our data set. So as you can see, everything is stored inside one table. All the attributes like segment, country, product, all the numeric values like discounts, gross sales, sales, profit, and so on, and all the date attributes. So in an ideal world, we talked about star schema. In an ideal world, you have a proper date dimension and all the date attributes are stored inside that dimension. You have a proper segment dimension and then all the segment attributes are stored in that dimension, and so on and so on. So how it's done with Power Query? I'll open Power Query editor, and let's duplicate this query. So let's call this one segment. This will be a segment dimension. Then let's duplicate once more, and let's call this one country. We also need one for product. So I'm creating a couple of duplicates of our original query. And we need date. And finally, we need something like sales, right? So let's now create our dimension tables. So in this case, we have just a segment attribute. In real life, you can have multiple attributes that describe segment. Instead of keeping them within a single table, what we can do, we can isolate these attributes related to segment. So what I'm going to do, I will click on the segment column, remove other columns, and then remove duplicates. So we have just unique values that exist for this segment, and I will sort them in ascending order. Then, as a recommended practice is to create so-called surrogate keys, which are used in dimensional modeling for establishing relationships between tables and to guarantee uniqueness of the records in dimension tables. So I will go to add column and then index column. Let's start from 1, and let's call this one segment key. Okay, and then I'll put this in the first place. So now we have our segment dimension. Let's do the same thing for country. So I'll remove other columns, remove duplicates, sort this in ascending order, add index column starting from 1. Let's call this one country key, and let's put it as a leading column. For product, we are doing the same thing, removing other columns, removing duplicates, sorting this in ascending order, creating an index column. Let's call this one product key. For date, we have a couple of attributes. This is a good example. So for dates, we will have date, month number, month name, and year. These are all attributes that describe date. So we'll remove other columns. Again, remove duplicates. And in this case, we don't need to create a surrogate key with index column because we are going to use date column as the unique identifier to connect to our fact table. And finally, in our sales table, what I'm going to do, I will basically create or bring these surrogate keys, these numeric values, as foreign keys to our dimension tables. So let's go to merge queries. So what I'm going to do, I will merge query on the segment column, segment and segment, do the left outer join, click OK. And then once I'm expanding this table, I will pick just the segment key, right? I don't need segment anymore because now I have the segment information describer, segment describer inside dimension table. So I'll keep just the key column. Okay, let's do the same for product and country. So merge queries, country, like this. And again, keeping only the key column. And let's do the same thing for product. So product and product. And picking our product key here. Okay. For date, we don't need to do this. We don't need to merge because we already have date information here. But now, since we have key columns that we are going to use to establish relationships, I can get rid of all these descriptive columns here. So I can remove these columns. And I can also remove all the columns that are relevant for dates. So all these date-related attributes. So remove columns. Now what we have a narrow, tiny fact table called sales that contains only numeric values. So units sold, manufacturing price, sale price, and so on, and foreign key columns to our dimension tables. Because we don't need our big flat table for our end users, I will again right click on it and disable its load. So it doesn't end up in our final Power BI solution, because we want to use our proper star schema model instead. Once I click close and apply, Power BI will load this data. And once I go to a model view, you can see something that reminds of, let's create a relationship here, something that reminds of a star. So what we just did, we broke down the big flat table into a proper star schema, and from this moment we can use this model as a proper model for our Power BI solution. Don't forget, star schema should be your default choice and your preferred option when designing semantic models. Reasons are different. Let me just pull, I promise I will pull the link from the official Microsoft documentation. So I'll share this right now with you. Give me a second. So this is star schema guidance, contains a lot of useful resources and information about creating a star schema and why star schema is the preferred model for Power BI. There is a question, can you describe why did you choose duplicating the query, not referencing the query in this demo? Great question, great question. I could do with reference as well, but yeah, I started with duplicate for the first one. That's the only reason. There is no other reason. But that's a great question. Maybe I can quickly show the difference between duplicate and reference. Thanks for bringing this question. Totally makes sense. So what I did, I created the duplicate of the query. And when you create a duplicate, this is what is going to happen. So all the transformation steps will be transferred to a duplicated query. So this is with duplicate. And then from here, I can make changes to the original one. So for example, I can calculate something like, I don't know, I can add additional column, which is multiplying, let's say, units sold multiplied by 1.2, and it will create a new column. Okay, so this one now exists in the original query, but in my duplicated query doesn't exist. So these two now continue to live their own lives, right? So they're totally independent. If I create, so let me delete this. We start from scratch. If I create a reference, with reference, I just have one step, which is basically the final result of the base query. In this case, if I go back and create another, again, custom column, which is units sold multiplied by 1.2. So this column now exists in the base query, but this column now also exists in my reference query. So all the changes I make to the original query will affect the reference query. That's the difference. But in this example for star schema that I created, there is no big deal. You can use both, but these are the differences that you should be aware. And thanks again for bringing this question. Okay, any other questions? Good, then let's proceed to our next big topic, which is design data model. The efficient data model is at the heart of every successful Power BI implementation. And I know we all enjoy creating and designing nice looking charts and visuals, but most often a well-designed data model is what makes the difference between glory and failure when implementing Power BI solutions. So let's talk about different aspects of data modeling in Power BI. I'll first talk about relationships. And relationships are one of the key concepts in data modeling. Unlike in traditional relational database scenarios, when we cared only about the relationship cardinality, in Power BI semantic models, relationships also serve as filters between the tables. when we are running DAX calculations, as we will learn later today when we start talking about DAX. So let's first examine the concept of relationship cardinality. There are 4 possible options to choose from: one-to-many, many-to-one, one-to-one, and many-to-many. The one side of the relationship means that the column contains unique values, whereas the many side means that the column may contain, that the column may contain duplicate values. One-to-many and many-to-one relationships are essentially the same. The only difference is where the relationship starts from, meaning in which direction filter is propagating. Let's examine this on a very simple example. Let's say that we have 2 tables in our semantic model, product and sales. There is a product key column in both tables, and we create a relationship between 2 tables on that common column. However, since the product key in the product table contains unique values only, if we define a relationship from this column to the product key column in the sales table, this will be a one-to-many relationship. If we do the opposite, so if the relationship goes from the sales table to the product table, it's going to be a many-to-one relationship. One-to-many and many-to-one should be your preferred choice when designing Power BI semantic models. Again, in this on this link that I shared about star schema guidance, there is also guidance about creating relationships. And you will see that the recommended way of handling relationships is to have one-to-many or many-to-one relationships. Avoid one-to-one at all costs. One-to-one is really a sign of suboptimal model design. Many-to-many has its own use cases, but still many-to-many should be considered as an exception rather than the rule. So this is preferred choice in Power BI. When you have requirements, or let's say those use cases for many-to-many, there are certain scenarios when these many-to-many must be implemented, such as, for example, connecting tables, fact tables with different grain, or connecting many-to-many dimensions. And good example of many-to-many dimension is a model that contains 2 tables, account and customer. One customer can have multiple accounts. Also, one account can be shared by multiple customers. So this is typical many-to-many requirement. In this scenario, a recommended practice in Power BI is to create a so-called bridge table, which stores a unique combination of each customer and account, and then we create 2 one-to-many relationships between our dimension tables and the bridge table. That is a recommended practice. Another important concept when designing relationships is filter direction. There are 2 possible options here to choose from: single direction, which is again a recommended practice, and both directions, or bidirectional, which has its use cases but should be implemented with special care. So to wrap up the story about relationships, you should tend to have one-to-many relationships with a single filter direction. That's a recommended way of doing things. How this works? The arrow on the relationship reveals the filter direction. In this case, we are talking about a single filter direction going from the product category table, then to the product table, and then all the way to the sales table. This means we can filter values in both product and sales table by selecting a value in the product category table, but not the other way around. This is important. But if I set a filter direction to both, or bidirectional, then we would be able to propagate filter values in both directions. Bidirectional relationships, if you go and search on web or your favorite large language model chat, you will see that bidirectional relationships are usually, so people are telling stay away from this, stay away from them. And I agree with that, but obviously there will be some use cases where you need to go this way. So what I'm saying, bidirectional relationships are not evil per se, just make sure that you know what you are doing if you are enabling bidirectional filtering through the relationship. So they should be used really with a special care and really with some within some special scenarios. So you should try to avoid them, and in most cases you can avoid them by using a special DAX function called cross filter. We'll talk about cross filter function later during the DAX part. So if you have a question in the PL-300 which asks you how to enable filter in both directions on the relationships just for the sake of the single DAX calculation, the answer is cross filter function. So that's the function that allows you to enable bidirectional filtering just during the execution of that particular DAX calculation. Normally, this relationship has a single direction filter, but for the purpose of that particular calculation, you can open it in both directions by using cross filter function. So basically what cross filter function allows you to do is to change the default filter direction or to overwrite it. This means you can change the default filter behavior to just for the duration of the specific query execution. So columns that are part of the relationship and direction for the filter, that can be set to both none or one way. One way is a default one if the filter is applied. Okay, so the next is role-playing dimensions in our model. Have you ever been to a theater? When I heard, I have to be honest, when I heard the term role-playing dimensions for the first time, my first association was theater, probably because of the words role and playing. For all of you who read Kimball's book, you will find role-playing dimensions explained over there. And as in real theater, basically, you can where you can hire two actors to, and each of these actors played a single role. You may also rely on one actor to cover both roles. Similarly, if you think that way, similarly you can do with your semantic model and dimensions in your semantic model. Before I show you how this story about actors and roles reflects in the data modeling world, I would like to emphasize that the role-playing dimension is not a concept exclusively related to Power BI. So as I said, it's a universal data modeling technique from this Kimball's methodology and dimensional modeling. So what's the idea behind role-playing dimension is to basically you have the situation when you use one same dimension for creating multiple relationships to your fact table. Typical usage of role-playing dimension concept is with date dimension, because in many cases your fact table will contain multiple date fields. For example, in the sales table, there are fields like order date, ship date, and due date, which don't need to be identical. And in most cases, they are not identical. Although the role-playing dimension concept is not exclusively related to Power BI, there are certain nuances for its implementation in Power BI models. One of them is the special DAX function called use relationship. We will cover DAX, again, as I said, in more detail later. But briefly, I will explain here what the use relationship function is doing in data modeling scenarios. First of all, in Power BI semantic model, you will be allowed to create multiple relationships between two tables in the model. So this is supported, you can do that. But only one relationship can be active at a time. So you can create 10 relationships between two tables, but just one can be active at a time. In some scenarios, you want to switch active relationships, and that's where the use relationship function comes to the rescue, because it allows you to activate the inactive relationship just for that specific calculation. I will show you this in a demo, but use relationship function is something that we are using for that. There is a question by adding the bridge table, will the model convert to Snowflake? Not really. So Snowflake model assumes that you normalize dimension tables. In this case, we are not normalizing them. We are breaking basically this into another table that is that combines unique values from both tables. So it's not a snowflake schema, it's still star schema, but just for the sake of eliminating many-to-many relationship, we are introducing this bridge table. In case we are further normalizing the existing table from star schema model, then we would have created a snowflake model. But that's a great question, thank you. Okay, before we move on to a demo, one more topic, it's creating a common date table. Now, every proper date model should contain a dedicated date or calendar dimension. This does not apply to Power BI exclusively, but generally for any business intelligence solution. We are talking about scenarios for analyzing data by different date attributes, such as calendar year, fiscal year, quarter, month, and so on. Moreover, specifically for Power BI scenarios, it is even more important because it enables usage of the built-in time intelligence DAX functions that we are going to examine when we talk about DAX in the next part. There is probably no single use case where our users don't need to slice and dice data based on the time and perform various comparisons between periods. And although Power BI offers the auto date time feature for handling time-based analysis out of the box, I would strongly advise against using this feature for a couple of reasons. Instead, you should definitely create a separate and dedicated date or calendar table in your data model. There are multiple options to create a date table. First, and probably the most desirable, is to leverage the existing date dimension from the source system. Chances are that your data warehouse or your source system already contains properly well-designed date dimension that includes all the necessary attributes, maybe even some extra attributes that are specific to your business, like holidays, for example, fiscal years, and so on. The next option is to use Power Query. There are dozens of ready-made scripts you can use. You can copy and paste just in your Power Query editor, either from web or from ChatGPT, Claude, whatever you're using. So you don't need to reinvent the wheel. There are already scripts that exist out there. And finally, you can also create a date table using DAX. There are two specific functions, calendar and calendar auto. Those are built-in functions that enable quick and easy creation of the date table. Okay, let's move on to the next demo, and I'll show you how to implement a role-playing dimension, how to configure relationship cardinality and cross-filter direction, and how to create a calendar table. So let me share my screen. Okay, and go off the camera so you have more space. Okay, so let's first implement a role-playing dimension. I will close this one. We don't need it anymore. Don't save. I'm going back to my original file that we've been using throughout the training today. So let's first implement a role-playing dimension. What we have, and when we talk about the role-playing dimension, so if I go to a model view, this is a little bit cluttered. So what I'm going to do quickly is to create another solution. Or maybe I can use the existing one. I'll just create a new layout. Let's do that. So I'll create a new layout, and then I'll take dim customer, dim date, dim product, and for example, fact internet sales. So our very simple star schema. As you can see, there is Power BI automatically identified relationships between product and customer dimensions and our internet sales tables, because there is only one product key column in and customer key column in dimension tables. But for date table, it's not capable of doing that. Why? Because we have multiple date columns inside the fact table. So Power BI doesn't know which one we want to use for creating a relationship. If you can take a thorough look, we have a due date, we have an order date, and we have ship date. So 3 different date columns. So let's say that our default, or that our users need to see data, so total sales amount for due date, for ship date, and for order date. There are 2 ways to implement role-playing dimensions. So what I can do, I can duplicate this dim date table and create, for example, something like this. So this is our key column, full date alternate key. I create a relationship to order date, and then I call this one, for example, dim date order. Then I go and create a duplicate of this query. Where is my dim date? Dim date order is now called. So I'll duplicate this one, and once more. So I'll create, I have 3 versions of my dim date table. This one will be called dim date due, and the last one will be called dim date ship. You can assume where I'm going with this. Once I hit close and apply, Power BI will load these new tables into model. So what I'm going to do, I'll put them here, dim date due and dim date ship. And then I create the relationship between full date alternate key and ship date, one-to-many relationship, life is good. And here I create full date alternate key and due date. Now, there is nothing wrong with this approach, except that it adds to a model complexity. That's the first problem. Because imagine that you have 10 date columns in your fact table. Then you would need to create 10 copies of the same date table. That's the first problem. The second problem is that if a user wants to see a comparison of the sales amount between order and ship date on the same visual, with this approach, they can't do that, right? Because if I create something like this, so I put a table and let's put, so I need to pick something from my dim date order. Let's say that's my default one. And if I put, for example, full date alternate key, and I put sales amount, so something like this, right? If I want to put also due date or ship date here, I can't do that because I'm already using a column from the table that has a relationship on the order date. So in case you have a requirement that user has to analyze numbers on the same visual based on different dates, instead of creating a model like I did here, so I will now delete this from model, and I'll delete this one from model, and let's rename this back to dim date. So I will leave this current relationship between the order date and full date alternate key, but what else I can do? In addition, I will create additional relationships. So between full date alternate key and ship date, okay? And between full date alternate key and due date. What we can see here is that we have 3 relationships, 3 existing relationships going from here to here, but 2 of them are marked with a dashed line. This means that these relationships are inactive. So by default, every calculation that happens in Power BI report will use the active relationship, which is on order date. So how can we leverage these 2 inactive relationships to calculate our numbers? So what I can do, I can go back to my report, and then let's create a new measure. Don't pay too much attention if you don't understand all the details. We'll talk about DAX in just a couple of minutes. This is just to show you from a modeling point of view how DAX can be leveraged to implement this role-playing dimension concept. So let's say I want to display on the same visual sales amount based on due date. And the calculation for this formula, so we will use the calculate function. Again, we'll talk about it in detail very soon. And what we want to calculate sales amount. And we need to activate our inactive relationship. This is done with use relationship function. So basically we need to provide our full date alternate key. That's the column from our dim date table. And instead of order date, which is a default one for the active relationship, we want to use due date from our fact internet sales table. Closing the brackets, and let's confirm this. So what I can do now, I can use the same full date alternate key column, and I can show a comparison based on the due date versus order date. So this one calculates this one. This calculation here activates the inactive relationship, the one with dashed line, activates it just during the execution of this particular query. So we can basically leverage one copy of the date dimension in multiple different roles. That's why it's called role-playing dimension. It's playing different roles. Roles of the order date, roles of the due date, and potentially, if I create another calculation, roles of the ship date. This is a role-playing dimension. Let's go back to our model and explore how to configure relationship cardinality and cross-filter direction. So once you hover over the relationship or click on it, you can configure relationship inside its properties. So you can change the table, the column, cardinality, and so on. Or you can right-click on it, select properties, and then inside this dialog window called Edit Relationship, you can change columns, tables, and again, here, you can pick between many-to-one. As we already mentioned, there are 4 options: many-to-one, one-to-one, one-to-many, and many-to-many. If Power BI identifies, so for example, if I try to create one-to-one relationship, it will check validity of this relationship cardinality, and it will throw an error. Basically, it says that I can't do one-on-one, one-to-one, because there are duplicates in my fact internet sales table. Why? Because on one day we have multiple sales, right? So we can't create one-to-one. Many-to-many, again, there is a warning. This time I can proceed with that, but it says this relationship has cardinality many-to-many, and this should only be used if it is expected that neither column contains unique value, and that the significantly different behavior of many-to-many relationship is understood. That's why we said that many-to-many should be considered as an exception rather than a rule, and that when you have these requirements, you should go with a bridge table in between. So you can create this. So I can click Save, and now it will create many-to-many relationship, right? The first thing you can notice is that this line here, this relationship between dim date and fact sales table is different than this one that goes from the product table. So there is a blank space here and blank space here. Whenever you are using many-to-many relationship, one of the consequences is a creation of so-called limited relationship. As you may assume based on its name, limited relationship comes with a lot of limitations. So this should be avoided at any cost if possible. Like in this case, we really don't need many-to-many, so I can revert it back to not one-to-one, one-to-many. Oh, sorry, in this case it's many-to-one because it goes from fact internet sales to dim date, so it's many-to-one. And now what we have here, another thing to analyze is the filter direction. Compare this arrow here and these arrows here with this one. So the arrow shows the filter direction, which means that whenever user selects something from here, like full date alternate key, this filter will propagate and filter out the values from the fact table. But if the user selects something like order date here, this selection will not propagate, or not order date, this is wrong. if they select ship date, this will not propagate back to dim date because the filter direction goes from dim date to fact internet sales, not the other way around. But for the order date, if I select something in the order date, this will also filter out the values in dim date because the relationship is open in both directions. It's fairly simple to understand implications with this small model with 4 tables. Another consequence of opening this relationship in both directions is this one. If I select something from dim customer, it will filter out my fact table. But since there is a filter propagating from the fact table to the date table, this selection here doesn't stop at the fact table. It also goes all the way to the date table. Again, it's easy to understand in a model with 4 tables, but in real life, you will have models with 20, 30, 50 tables. And if you enable bidirectional relationship, trust me, you will get lost. You will not understand how the numbers are produced and what is filtering what. So again, bidirectional filters should be implemented with a special care. As a recommended practice, you should have a model like this with one-to-many relationships and with single direction filter. And one last thing I want to show you is how to create a calendar table. So in this case, we have a calendar table that is already here from our source system, from our source database. But in case you need to create it, to create your own date table, say you don't have a proper data warehouse, you can do that using either Power Query or using DAX. I will show you how to create it using DAX. So I'm back in the report view, and once I go to table view and select table tools, new table, this is the DAX formula that I'm going to use just to show you. So basically I'm leveraging calendar, built-in calendar function, and here I'm specifying where my date table will start and end, and those are the columns that I'm going to use. So year, month number, month name, quarter, and day of week. Everything, I'm extracting everything from this original column that I'm creating here. Once I click OK, here is my date dimension, my calendar dimension created using DAX. So it's as easy as that. Of course, there are many more complex solutions if you need with fiscal years, again, public holidays and everything else, but not having a proper date dimension from your source system is not an excuse to use auto-date time feature in Power BI. So it's as easy as that to create a proper date dimension also using either Power Query or using DAX. Okay, any questions before we move on? I don't see any new questions in Q&A or in the chat. Okay, then I suppose we are good to go. Okay, let's start with another big topic, probably not a favorite one. I know people who work with Power BI are not big fans of DAX, but yeah, that's something that you definitely need to learn if you plan to work with DAX seriously. I see some thumbs up, yeah, okay. Before we start with DAX, I have a question for you. What is your experience with DAX? You're probably wondering, what does this response E, I speak DAX like an Italian, mean? I promise I'll explain this, but let's first wait for your responses. 20 more seconds to give everyone a chance to respond. Again, don't worry if you answered A, what is DAX? We start by explaining what DAX is. So that's totally fine. Ten more seconds. Okay. So, oh, we have someone speaking DAX like in Italian. That's amazing. Most of you heard of DAX but never use it or familiar with basic DAX concepts. That's great. So I owe an explanation for this last option. I speak DAX like in Italian. I'm sure that person who picked that option knows what I'm talking about. In our Power BI community, basically biggest experts when it comes to DAX are considered two Italian guys, Marco Russo and Alberto Ferrari. So we are always joking. We have some internal jokes. If you know DAX, you speak DAX like in Italian. So that means you are super proficient with DAX. That's why I included this option. And again, if you want to learn DAX and master DAX, they have a great book called Definitive Guide to DAX, recently with the 3rd edition. So if you want to dive deep, but it's like 800-900 pages. So it's a tough one, but it's really amazing for learning and understanding DAX. Thanks everyone for taking time to respond. And before we dive deep into the trenches of DAX formulas and calculations, let's get back to basics, of course, and first explain what DAX is. DAX stands for Data Analysis Expressions. That's the functional programming language that can be exclusively used in Microsoft's set of products, namely Power BI Analysis Services and Power Pivot in Excel. So you can't use DAX anywhere outside of these three products. So DAX formulas, they include various functions, operators, and values, which are used to perform advanced calculations and queries. DAX formulas can be leveraged to create three types of objects: measures, calculated columns, and calculated tables. Let's now examine each of these three in more detail. Measures are really the bread and butter of the DAX language. And I created one of the measures. I created one measure in one of the previous demos with the role-playing dimensions. That's an example of a measure. I also created a calculated table in one of the previous examples with creating a date dimension with DAX. So essentially, let's start with the measures. As I said, these are really bread and butter of the entire DAX language. The key characteristic of measures is that they are computed on the fly, which means that they are not pre-calculated and stored in the data model. On the opposite, the measure value is determined only when the measure is used in the report. This dynamic nature of the measure ensures that the value is updated in real time and it's responsive to user interactions with the report. You can recognize measures in the model based on the calculator icon next to the measure name. There are two types of measures: implicit and explicit measures. Quick measures are a third type, but it's not so relevant for this part for understanding. So implicit measure is automatically created, or let's say it's implicitly created when you start working with Power BI. So whenever you have a numeric column in your data set, Power BI will automatically apply aggregation to it using functions like sum, count, average, or similar. This automatic aggregation is called an implicit measure, and it's indicated by the sigma symbol next to the column name. You can modify or disable implicit measures by adjusting the default summarization settings. Again, I will show you soon this in a demo. On the other hand, explicit measures are intentionally created measures by Power BI developer by writing a DAX calculation in the formula bar or DAX query view. With explicit measures, you are in charge and you have a full control over the expression logic. Explicit measures can also be reused and referenced by other explicit measures. And generally speaking, when you are designing a Power BI data model explicit measures should always be prioritized and used over implicit measures. Quick measures, just to briefly mention them, these are one of the, I call them hidden gems in Power BI. Many people are not even aware of them, but they can come in very handy in various scenarios. So in a nutshell, quick measures represent DAX templates for common calculations, such as running totals, year-over-year comparison, and many more, of course. The key benefit of using quick measures, of course, except from saving some time and effort along the way, is the possibility of learning and better understanding DAX. Why? Because once you create a quick measure, you can open the DAX formula and see the DAX code that is automatically generated to apply this desired calculation. Let's now talk about calculated columns. Calculated column in Power BI represents an extension of the table that uses a DAX formula to evaluate values on a row-by-row basis. Unlike measures that are calculated on demand, calculated columns are computed, so pre-computed and stored in the data model itself. Calculated columns may be useful in scenarios when we need an additional helper or connector column in the table, but please keep in mind that these columns are being recalculated during the data refresh process, which might impact the data refresh process performance. So again, a recommended practice is to avoid and limit usage of DAX calculated columns whenever possible. You will recognize calculated columns in the model by the table and sigma icon next to the table name. And finally, we have calculated tables. So from a technical perspective, they are very similar to the calculated columns that we already examined in this previous slide. As you might have rightly assumed, the key difference is that in this case, we use DAX to create the entire table instead of a single column. Calculated tables are also computed and stored in the data model, so essentially they are increasing the overall memory footprint of the data model. Calculated tables are commonly used to enhance the data model with additional tables based on the existing data. You can recognize calculated tables based on the table and calculator icon next to the table name. Some of the commonly used DAX functions to create calculated tables, we'll see some of them in a demo. Maybe the most interesting thing to keep in mind here is the difference between the distinct and the values function, which produce very similar results. Distinct returns a table of all distinct values in the column, skipping any blank values, whereas the values function will do the same, but it will also return the additional blank row in case of invalid relationship. So those are calendar and calendar auto we saw previously with creating a data measure. So to explore key differences between calculated columns and measures in DAX, I think this is one of the biggest confusion points for many Power BI developers, especially new Power BI developers. The fundamental difference is that a calculated column creates a value for each row in a table, which implies that calculated column expression can only operate over columns that exist in the same table. Simply said, if the table contains 500 rows, the calculated column will also contain 500 values. On the flip side, measures are calculated on demand only when the user needs the calculation in the report. Calculated column values are stored in the model, which means that they increase the overall data model size. On the other hand, measures don't affect data model size, since only the measure definition is stored, not the physical values. Performance-wise, calculated columns are calculated on a row-by-row basis, which may affect the performance depending on the size of the table, especially we are talking about larger models. However, this doesn't mean that measures will perform great by default. Again, DAX expressions used for creating measures may still be suboptimal and you can still face performance issues. And finally, calculated columns must be referenced with measures for reuse, whereas some measures measure can reference other measures directly for use. So you don't need to prefix it with any table. Okay, we are now moving to explain the calculate function, which is very important and I would say a little bit complicated topic. So I suggest we take another short break before we dive into explaining filter context and how calculate function can be used to manipulate the filter context index. So let's take a short break of 10 minutes again, and then I'll see you in 10 minutes, and then we continue our learning journey. Enjoy the break and see you soon. The second break, just a quick, let me see, quick check that everyone is feeling well and ready to continue. Can I see your thumbs up or thumbs down? Hopefully not, thumbs down. I know it's been 3 hours, so I guess you are maybe a little bit tired, but I hope you are still very motivated to finish this day one with a style. So maybe just a quick pulse check. Okay, I see claps, thumbs ups, celebrations, hearts. Amazing, thanks, thanks. That's good to hear. That's good to hear, because the next part is one of the most intimidating part of this entire training, because we're not talking just about DAX, we're talking about some specific concepts that also makes DAX, let's say, a beast on its own within the Power BI. But once you master these core concepts and how the calculate function works behind the scenes, I'm pretty sure that you will start loving DAX, and I'm sure that you will build more powerful Power BI solutions. So let's jump straight into the explaining the calculate function. Okay, so calculate function, together with its sister calculate table function, is the only function that can change the filter context in DAX. So it's extremely powerful. So as you know, with great power comes usually great responsibility, and that's why I said that it's of paramount importance to deeply understand how calculate function works under the hood. Before we dive into demo, you'll need to learn a little bit of a theory. First, as I mentioned, that calculate can change the filter context. That's the only function that can change the filter context. You might be wondering, what is a filter context? So let's first explain this. Filter context refers to the set of filters applied to the data. And this set of filters influences how calculations and measures are computed and displayed in Power BI report. Let's take a look at a very basic example. Our report contains 3 visuals. In each of these visuals, we are using the exactly the same DAX measure with the same expression. It's called total sales. The visual on the left side displays the total sales measures without any filters applied. So it's total sales measure across the entire data set. The one in the middle is filtered by country. And finally, the visual on the right-hand side is filtered by the product. Even though the measure was defined only once, each of these visuals evaluates it and displays it differently. This is the filter context in which the DAX expression has been evaluated. So the first and most important creator of the filter context is the visual itself. Or in simple words, depending on what you put in the visual, these categories that you put in the visual will create filter context. That's the first way to produce filter context. Second way to produce filter context is by using filter panel. We will talk in detail about filter panel tomorrow, but filter panel is used to, as its name suggests, to filter out some data from the report. So the filter panel also affects the filter context. The third way to create the filter context is by other visuals on the report page. So for example, if you're using a slicer visual, user picking value in the slicer will affect, by default, it will affect numbers, or it will create, it will produce the filter context for numbers on the entire report page. So this is the third option. So we have the current visual, filter context produced by the current visual, filter context produced by the filter panel, filter context produced by other visuals on the report page. And then the fourth way of creating the filter context is by using DAX, and particularly using calculate function. That's the only one that can be used to change the filter context. Now let's take a look behind the calculate inner working. In this example, let's imagine that I'm writing a DAX statement to calculate the sum of the sales amount in my sales table. There might be an existing filter context in which this calculation will be evaluated, but for the sake of simplicity, let's pretend that it's currently blank. So nothing affects this calculation. Now let's try to understand what we have inside the calculate function. No matter how strange this might sound, the first argument of the function, which is the expression we want to calculate, is not important at this point in time. So let's think of it as it was frozen. And then we have one or more filter modifiers. This part of the calculate function is evaluated first. This is extremely important to keep in mind. Here is what is going to happen here. Power BI will create a virtual table for each filter modifier. In this case, we have 2 filter modifiers. The first table contains a column product key and the value that is equal to 226. The second virtual table also contains one column, customer key, and the value 123 in that column. Now bear with me. These 2 tables will be added to the existing filter context and will produce a modified filter context. And finally, our expression from the first argument will be unfrozen and executed in this modified filter context. Now, there are multiple filter modifiers you can use inside the calculate function, such as the keep filter function, user relationship, the one that we already saw in action with role-playing dimensions, cross filter, the one that allows you to enable bidirectional filtering through the relationship for the sake of particular calculation, and the so-called all family of functions, such as all except, all selected, all no blank row, and remove filters. So those are all filter modifiers inside calculate. These functions that you see here on this slide, they can't modify default filter context on their own. Calculate is the function that does this. These functions that you see here are just modifiers inside the calculate. Depending on the use case, they will behave differently, but inside the calculate, they operate inside the calculate function. I will show you in a demo, so don't stress too much right now. Time intelligence DAX functions offer out-of-the-box solutions to many business requirements related to calculations which are relevant for comparison and aggregations over different time periods, like days, weeks, months, quarters, years, fiscal years, and so on. To be able to take advantage of time intelligence functions, you need to fulfill certain prerequisites. So first of all, you must have a well-designed calendar table in your Power BI data model. Then you need to have continuous dates in that table, starting from January 1st and ending on December 31st, including all the dates within that range. Then there has to be a column of date time or date data type containing unique values. And finally, the table must be marked as a date table in the data model in case the relationship between the calendar table and any other table is not based on the date. So these are the prerequisites for time intelligence measures. Understanding the logic of semi-additive measures is one of the biggest challenges for many developers. This is valid not only for DAX developers, just to be clear, but for, I would say, any BI developer. Although the calculation itself is not so complex, the most challenging part is to understand the desired behavior of the measure. Unlike additive measures that uses sum over every single attribute in the model, or non-additive measures that don't use sum over any attribute, semi-additive measures use sum over some dimension attributes and a different aggregation type over other dimension attributes. A typical example of semi-additive measures is a balance amount, which is additive across all dimensions except time. Because yeah, it would be quite awkward if we all of a sudden start to add up values of the bank balance or, I don't know, inventory counts, for example. So let's examine a few of the DAX functions used to implement semi-additive calculations. Those are first date and last date time intelligence functions, then first no blank and last non-blank, as well as special functions for calculating balances, such as opening balance year, closing balance year, opening balance month, opening balance, closing balance month, and so on. And after that, I will show you this in a demo, couple of these in action. So another topic that belongs to DAX is called create calculation groups. But before I show you again in a demo how to create a calculation group, let's first try to answer the simple question. What are the calculation groups? Instead of giving you a dry definition of the calculation groups, I'll try to share a descriptive version. Imagine that you have a fact table which contains 10 different calculations, 10 different metrics, like sales amount, sales quantity, discount amount, return amount, and so on. As every serious Power BI developer, you'll go and create 10 explicit measures for each of these metrics. The next step is to provide your business users with additional information. For example, what was my sales amount in the previous quarter, or how my sales quantity developed year over year, or what is the running total of the return quantity for the selected time period. So How do you achieve this? Of course, you will write a measure to calculate the sales amount for the previous month, then sales amount for the previous quarter, then sales amount for the previous year. Then you will write the same set of calculations for order quantity, then for return quantity, and so on. So you quickly end up with 50, if not more than 50 measures in your semantic model. And most of them contain basically redundant logic. You're just copy pasting the expression and switching to the base measure, like from sales amount to order quantity, then to return quantity, and so on. And here calculation groups come to the rescue. With a calculation group, you set a placeholder for the specific base measure, for example, sales amount, and then you define a set of calculation items that will be applied to that placeholder measure. I know it sounds a little bit confusing, so let me show you a very simple example of the placeholder measure and the calculation items. So placeholder measure is defined by using the selected measure. This is a special DAX function, which evaluates the measure that is currently in the context. Then we have calculation items for this measure in the context. In this case, I've created two calculation items. One is month-to-date calculation, which is on your right side, and year-to-date calculation on your left. As you see, the only difference is the calculate filter modifier. There are no two separate measures anymore. It's just a single base measure in the scope. For example, in this case, sales amount. And this is how calculation groups look in the report. So let's jump into a demo and see these different DAX approaches and concepts in action. So I'll show you how to create calculated columns and measures, how to leverage the calculate function to manipulate the filter context, implement some of the time intelligence DAX functions, create a calculation group, and so on. Okay, so let me share my screen. And go off the camera. So we make some additional space. Okay, for this demo, I have another file because I already prepared some calculations in advance, just for the sake of timings and covering everything without sacrificing starting from scratch and all these things. So basically what I have is the same data set. It's AdventureWorks database. Again, customer date, product, sales, everything that you already saw. This is just for particular DAX use cases. So what I wanted to show you here is a very simple table visual that contains so total sales amount for every single product color. First of all, let's understand the filter context. So in this case, filter context is produced by the product color, which is part of the visual. Now, if I also add, for example, education of the customer, look what happens with the sales amount values. They've been changed. I didn't rewrite my calculation logic. I'm using the same calculation itself, but now the calculation is evaluated in a different filter context. In this case, filter context is produced by both product color and customer education. So this is the filter context of the current visual. And as we said, measures are calculated on the fly when user interacts with them in the report. They are not stored in the model. But what happens, remember previously we created a calculated column in Power Query that concatenates first and last name of the customer. We can do the same thing here inside Power BI Desktop using DAX. So if I click on three dots and then new column, I can say, let me just make this a little bit bigger, full name equals first name and last name. So this is our calculated column. You can recognize it based on the small column and FX sign. And Now, if I put this in a table visual, it will show me the concatenated full name column. The difference between these two, so let's remove this. The difference between the calculated column and the measure itself, so the measure is this one, CC sales amount. If I go to the table view and then go to a customer table, here you go, full name column is persisted, it's stored in the model. And we can see the value. For each row, we can see the value. If I now go to the measures table and then select, for example, sales amount, there is nothing to be displayed. Measures are stored just as a definition. They don't calculate any values in advance. No values are persisted in the model, so they are evaluated and calculated on the fly when user uses them in the report, like we do in this case when we use in this table visual. So this is the difference between let me just go back to demo slide so I know what to do. This is the main difference between the calculated column and calculated measure. Now I want to show you how to leverage a calculate function to change the default filter context. So I'll remove this education just to keep things as simple as possible. So maybe I can make this a little bit bigger so it's easier for you to follow. And let's give it a little more space like this. Okay, so basically this is the default filter context. Now imagine that I need to calculate the total sales amount, but instead of the default filter context, I want to display the value of the black color on each of these cells. So I can do that with calculate function. Inside the measures table, I'll create a new measure, and let's call this one sales black. And it equals, so whenever you want to change the default filter context, your DAX formula starts with a calculate. There is no other option. Calculate, and then what do we want to calculate? We want to calculate the sales amount. This is our calculation. The benefit of having explicit measures is that you can directly reference a measure that is already created, so I don't need to write again the same DAX function. And now, as you can see here in the IntelliSense, we need to provide filters. You can provide multiple filters. In this case, I want to provide my filter modifier for the calculate function, and this is going to be the filter function. So what I'm doing inside the filter function, I'm first removing all the active filters from the brand. Do I have a brand name inside a product? Let me see. No, we are working with the colors, right? So I'm removing all the active filters from the color column with all function, and then I'm enforcing my own filter, which says color, product color equals black. Closing these brackets. This is for filter, this is for calculate, and confirming this measure. Now, if I put this sales black into my table visual, look what happens. We have this number here displayed everywhere. So literally what we did in this calculation, we told Power BI, look, I don't care about the default filter context. I want to evaluate this expression here. I want to evaluate this expression here in my own context, in my own modified filter context. And I'm producing this modified filter context with this part here. So in this case, we are removing all the active filters from the color column and then imposing our own filter saying color equals black. I could have written this as a so-called syntax version, syntax sugar version, which is a shorter version. So I can remove this filter all to make this expression look a little bit simpler, although in the backend, your code will be executed as the previous one that I've shown you. So the result is exactly the same. We are just omitting filter and all part from the syntax. If you're just starting with DAX, I strongly encourage you to use the longer version. Why? Because in this case, you will better understand the execution logic of this particular DAX formula. With this shorter syntax, you may miss some important pieces here and there. So that's why I encourage all new DAX practitioners to start by writing the longer version of the calculation. And finally, so in this case, with both of these previous version of the filter modifier, what we were doing, we were basically overwriting the existing filter. So we told Power BI, you know, like take eraser, remove the current filter context, and we put our own filter context on this. What we can achieve to get a similar behavior is to use the keep filters function. Again, this is one of the calculate filter modifiers you probably recall from one of the previous slides. So if I use the keep filters as a filter modifier, look what happens now. Now we have this displayed in the row where we have a black color and we have blanks everywhere. Why? Because with keep filters, we are merging our filter with the existing filter. We are not overriding it, we are merging it. So instead of overwriting, we literally add an AND logical operation, which means that Power BI will evaluate this one and says whenever product equals black, this is the default filter, and my product equals black, we have this combination of these two conditions inside the data set, so we have the number returned. The next evaluation happens for the blue color, where Power BI says, let's find all the values where the product color equals blue and the product color equals black. This is our own filter. Because there is no such combination, each product belongs to one color, then there is blank here, because we don't have any product that satisfies this criteria. And for every single color, next color, it will evaluate product color equals red and product color equals black. Nothing, nothing, nothing. That's why we see blanks here. So this is slightly different behavior compared to the previous one without keep filters. So if we do something like this, then it overrides the existing filter. With keep filters, it adds our filter on top of the existing filter. Make sure to understand this difference. This is important for PL-300 if you get a question to debug a specific DAX calculation. Here I want to show you how to implement some common time intelligence DAX functions. So what I have here, I have a matrix visual that shows total sales amount for every year, quarter, and month. So I think I already created something. So I have, for example, order sales amount for the previous year. So if I put here sales amount for the previous year, it will show me this value here. Let me expand this so you can see this is on a quarter level, this is on a month level, and so on. So how this calculation is defined? Using same period last year, that's one of the options. So same period last year is the built-in time intelligence function that is used as a calculate filter modifier. So instead of the regular filter context produced by the visual itself, we want to shift our filter to the same period of the last year, and that's exactly what this calculation here is doing. I can also calculate running total, for example, sales amount year to date. It will calculate the running total, so this is the value, and then it adds this value, and it adds this value, and so on and so on. So this is done, this is performed by using sales amount year to date, dates year to date function. If you want to calculate total running total for the quarter, then you simply substitute Y with Q, so you get dates QTD, basically dates quarter to date or dates month to date. if you want to calculate the same thing based on a month level. Now you see what is going on here. We have a problem because I've created already 1, 2, 3, 4, 5, 8 different measures, which basically contain redundant logic. So in this example here, we have sales amount previous year, then we have order quantity previous year, and same set of calculations for every single measure. Now imagine if I create also return amount, tax amount, and then multiply this by 4, we will easily end up with a lot of clutter here. So instead of doing that, we can create a calculation group. So calculation group is created from the model view, but before that, this is our business requirement. Let's say we need to show all of these metrics inside one visual, and as you can see, I have how many? 1, 2, 3, 4, 8 different calculations. So with calculation group, what we can do, let's go to a model view, calculation group, and let's create a new calculation group. I'll click yes. So our base measure, let me make it a little bit bigger, is using selected measure as a placeholder. So this specific DEX function will evaluate any real measure that is currently in the scope. So if we are using sales amount and order quantity, it will use these two measures as a base measure. So I'll create a base measure, and then let's just rename this to CC column. Okay, and then in the calculation item, let's create calculation items that contain the same logic as here. So I'll simply copy the formula here and create this as a calculation item. So I'll call this CC order quantity, or let's call it just order quantity because we already have this measure with the same name, order quantity previous year. So what we are calculating, not the order quantity, but we are creating selected measure. So whatever is in the scope, we are creating here. Okay, so this is not going to be order quantity, this is going to be simply previous year, because if we select sales amount, the sales amount will be evaluated here. This is previous year, then let's take quarter to date. So I'll call this one, so let's copy the formula, create a new calculation item, and then let's call this one, this is quarter to date equals, instead of the sales amount, again, we are using selected measure. And what we have year to date. So I'll simply copy this, create a new calculation item, and then call this one year to date. This is going to be dates year to date. Now, if I go back to my report, and then I remove all of these things, so I'll just leave my sales amount, and here is our calculation group. And if I put this, so I have just a moment, I removed everything, that's my bad. So I need to leave sales amount and order quantity. These are our base measures. And now if I drag my calculation group column, it will show me all the calculations immediately. So instead of creating 8 different measures, I just create a base measure as a placeholder, and then Power BI will automatically evaluate it based on the calculation group. What's even better, you can do something like this. So you can put a slicer and then put your CC column on the slicer, and then decide I want to show just a base measure and the previous year, or just a base measure and quarter to date, or I want to show everything. That's also a possibility. So with calculation group, you are reducing the model complexity and basically removing this redundant logic from the model. Okay, any questions? don't see any new questions. Okay, then let's move on. Couple of more topics and then I'll let you work on the hands-on lab. Good, then let's move on to our next topic, which is not Q&A because Q&A are open all the time. So let's talk about optimizing model performance. When your report runs slow, the first question that comes to your mind is, where should I start? And that's a great question. Why? Because once you identify the area that causes poor performance, you can shift your focus to finding a solution to a more specific challenge, let's say. Whether it's the number of visuals, redundant data, complex calculations, or complex relationships, finding the root cause of the issues will let you put an individual problem under the spotlight. There are multiple different areas to examine if your report performs slow. Luckily, Power BI Desktop provides a built-in tool called Performance Analyzer that helps you capture the key metrics behind your report performance. When you're using Performance Analyzer, there are 3 different properties to understand. The first one is DirectQuery. So it allows you to identify these bottlenecks. The first one is DirectQuery, which shows the time elapsed from the moment visual sent the query up until results were returned from the underlying data source. Visual display, which shows the duration of the visual rendering on the screen, including the time spent retrieving images from the web, for example. And the third one, other, is the trickiest to understand. And for your information, you may expect to see it in PL-300, but you didn't hear this from me. Under this category, other, you should count the time necessary for preparing queries, waiting for other visuals to complete, or waiting for other background processing tasks to finish. If most of the total time goes under this category, under other, the most common issue is the huge number of visuals on your report page. So let's examine some of the techniques for optimizing Power BI reports. Okay, I am reading some messages. Calculation groups are used when it's repetitive and have the same logic, the computations. Absolutely, that's the best use case for calculation groups. Essentially, instead of using copy-paste for all the measures that you created, you create this logic just once, and then whatever measure is evaluated by the calculation group, these all calculations will be automatically applied on top of it. So it's a huge saver for and a huge thing for reducing model complexity. Let me see if there are any other questions. Okay. Okay, no more questions. Let's move on. So let's say we built our data model and we enhanced it with text calculations like we did in the previous part of the training. It's time to learn how to make this model more efficient. So we need to first identify which data is not necessary inside our semantic model. That's the first step. So when we are talking about which data is not necessary, so the data that we want to filter out in our Power BI solution, there are 2 types of filtering: vertical filtering and horizontal filtering. Vertical filtering means keeping only those columns that you need in the report. I know the question is, how do you know which columns you need in your reporting solution? Well, ask yourself if the specific column satisfies at least one of the following 2 prerequisites. If the column serves as part of the relationship or for defining security roles, then you should keep that column in the model because it's part of the model structure. Also, if the specific column enables you to achieve a proper report design, helps you group or summarize the data, and supports efficient filtering, this column should also make part of the model because it's part of the reporting design. The second concept is known as horizontal filtering. Simply said, you should keep only those rows you need. This one is a little bit more complex to answer on your own, as you should first talk and consult your report consumers before you make a final decision about horizontal filtering. I learned that harder way. That's why I'm sharing this story with you. So sometimes I thought, yeah, they don't need to analyze data from last 20 years, but it appears that you have analysts who are interested to see how things are developing from 1995 or so. So first talk to your report consumers before you remove or before you do this horizontal filtering. There are two main methods to achieve horizontal filtering. Filtering on the time dimension lets you exclude rows that are not necessary for the report. Again, if your users need to analyze data from the previous 2 years, there is really no need to import the data that is older than that. You can also filter by specific entity. Let's say that you're building a report for consumers in South America. I bet you can easily exclude rows referring to Europe, Africa, or Asia, for example. One of the key concepts to understand when determining which data to remove is called granularity. Granularity represents a level of detail in the dataset. To illustrate, if we are talking about time granularity, we can have our data stored on the level of precision measured in seconds, minutes, hours, days, or even months. There are multiple techniques to increase the level of details of the data, but before we examine some of them, the key thing to consider is what is the lowest acceptable granularity for the report users. If they need to analyze data on a daily level, you can easily exclude hours, minutes, and seconds from your dataset. If report consumers want to see figures on a product manufacturer level, without going deeper into each specific product, there is no need to keep a single product level of granularity in the model. But again, this is something that needs to be discussed with your end users. Now let's learn how choosing the optimal data type can reduce the cardinality levels of the column. Let's say that we have a column that contains data about the date and time when the product was purchased. Here in this example, my column stores the data on the minute level of granularity. And as you may see, we have 5 distinct values in the column, which means that cardinality equals 5. Now my report users want to analyze figures for every single day, but they don't care if someone made a purchase at 10:25 a.m. or at, I don't know, 5:45 p.m. So if I remove this time portion, my column will contain only one distinct value, and cardinality now equals 1. Don't forget, Power BI compresses the data by assigning indexes to these distinct values. So this means, in first example, this dictionary of distinct values will contain five distinct values, while in the second case, dictionary will contain only one value. A similar outcome can be achieved if you're dealing with decimal numbers. So let's say that your data is being stored on a level of granularity that shows 5 digits after the decimal point. Again, here is my column with 5 distinct values. If your report users don't need that level of precision, and you can round values to, let's say, 2 digits after the decimal point, you can again reduce cardinality, column cardinality to 1. Reducing the column cardinality helps Power BI to optimally compress the data. It helps to reduce the overall data model size, and consequentially your queries will run faster because the data is kept in memory. So this cardinality optimization is one of the techniques to improve performance of your Power BI queries. Okay, we are now talking about summarizing the data, which is particularly useful for large tables. So I have another question for you. What is the largest table that you have dealt with in Microsoft Power BI? be honest. Thirty more seconds, so we give a chance to everyone to respond. Ten more seconds. Okay, let's check. Okay, interesting results. Most of you, largest table was less than 10,000 records. That's really nothing in terms when it comes to Power BI. So probably you haven't faced any performance issues due to the large data model. But anyway, learning these techniques will help you in the future, because something that starts as a small model or small table can exponentially grow over time. I saw this many times in practice. So something that starts as a 10,000 records table after 6 months or after a year becomes 10 million record table. So it's good to know, and it's good to be aware of these various techniques for optimizing large data models. So you already learned what is granularity and how it directly correlates with cardinality levels. Remember, the lower the data granularity, the higher the column cardinality. And additionally, we've also talked how to improve cardinality levels by changing column data type. However, there is more to it. And what if I tell you that you can reduce the cardinality without changing the column data type? Summarization, another approach for optimizing large models. Summarization in synergy with grouping can help you achieve astonishing savings in your data model size. Let's start with the basics, like usual, before we explain how aggregations work in Power BI and take a look at some specific use cases. So let's first answer the following question. Why do we need aggregations in the first place? I mean, what is the benefit of having two tables that essentially contain identical data in your semantic model? Here is a short explanation of aggregations and the way they work in Power BI. And here is the scenario. Imagine you have a very large fact table, which may contain hundreds of millions or even billions of records. So how do you handle analytical queries over such a huge amount of data? You simply create aggregated tables. In reality, it's a very rare situation, or let's say it's, again, more of an exception than a rule, that the analytic requirement is to see the individual transaction or individual record at the lowest level of detail. In most scenarios, your users want to perform analysis over summarized data, like how much revenue we had on a specific day, or what was the total sales amount for product X, or how much did customer X spend in total, and so on. Additionally, you can aggregate the data over multiple attributes, which is usually the case in reality, and summarize figures for a specific date, customer, and product. If you're wondering what's the point in aggregating the data, well, the final goal is to reduce the number of rows and consequentially reduce the overall data model size by preparing the data in advance. So if I need to see the total sales amount spent by customer X on product Y in the first quarter of 2025 or 2026, I can then take advantage of having this data already summarized in advance. That's the benefit of using aggregations, so we are reducing the number of records, and consequentially we are reducing the overall data model size. Inside Power BI, aggregations have another level, let's say, which you can use, and using this special aggregations feature in Power BI requires you to make Power BI aware of aggregated tables. Again, I'll show you this in a demo in a couple of minutes, but keep in mind that it's not enough just to create aggregated tables. You need to make Power BI aware of these aggregated tables by using this manage aggregations special feature inside Power BI. Okay, let's proceed with a demo. I'll show you how to use Performance Analyzer to identify problematic elements and how to optimize data model by changing data types. So again, I'm gonna share my screen and go off the camera. Okay, so let's proceed. First of all, I want to show you how to leverage Performance Analyzer to capture performance of different metrics in your Power BI report. For that, I'm gonna use, let me find something where I have multiple elements on the report page. Maybe I can create something here. So let's make this a little bit smaller. So I will now mimic the behavior of the real Power BI reports, which usually consists of multiple elements on the report page. So let's put here something like, I don't know, product class and I don't know, order quantity. Then let's create another one where we will display sales amount based on, let's use education. And then let's create, for example, a table visual. Let's put it here. I'll put, for example, sales amount and sales amount previous year, or the quantity previous year, and then I'll put something from the date. So let's put column, calendar year as a column, and then let's put quarter like this. And finally, let's put month. Something like this. It doesn't matter, it's just to mimic the behavior for Performance Analyzer. Performance Analyzer can be accessed from two places in Power BI Desktop, either from the View tab here on the top, or from the Optimize tab also on the top. And here it is, Performance Analyzer. Once you click on it, it will open a new panel called Performance Analyzer. And once you hit start recording, from this moment, anything that happens on the report page, every interaction made by the report user will be captured and measured by Performance Analyzer. This means if I change something in this slicer, you will see that this action was captured, change the slicer, and you see the number of milliseconds for each element on the report page to render. So I can now go back and forth, or click here, click here, click here. So whatever I do, every action is captured by Performance Analyzer. Okay? So this was just to show you how Performance Analyzer works, but how do you actually analyze results provided by Performance Analyzer? So I'll clear this, and I hit refresh visuals. Now I can sort these results based on different criteria. So I can sort by total time. That's usually what I'm doing. And I'm sorting this in descending order. Why? Because this allows me to immediately capture the slowest element on the report page. In our case, it appears that this is a matrix visual. This one here, that's the slowest one. And if I click on this small plus sign, I can expand it and see how much time was spent on rendering this particular visual. So you can see the total time was 293 milliseconds. This is the time needed to execute DirectQuery. This is to render the visual on the report page. And as we said, this is the most important thing. This represents the time that this particular visual had to wait for other operations to complete before this visual could be executed. How Power BI works is that even though in this case, because everything happens super fast, you have a feeling that you have an impression basically that everything renders in parallel, but that's not the case. So every element renders in sequence. So once element number 1 is completed, then element number 2 starts to be processed. Then element number 3, element number 4, element number 5. And the more elements you have on the report page, this waiting time becomes higher. So in case you have 20 elements on the report page, or even more than that, that poor guy who is the last in the queue has to wait for all the previous elements to render before it could be handled. And this is where this other value can be really high. Usually that's a sign that you have too many elements on the report page, and that you should try to reduce the number of elements on the report page, for example, by creating a new report page and placing some elements on that new report page. Also for other elements here, so if I expand them, you'll see that for each of them, DEX is quite fast. And that's why I said that almost everything happens very quickly. Performance Analyzer comes with 2 additional handy features. One is copy query, where essentially you can copy the query generated by the DAX visual. So for example, let's say that this matrix visual, I identify this matrix visual as the culprit for the slow performance of my report. I want to analyze it in more detail. I can click copy query, and then, for example, open a special tool such as DAX Studio, for example, free tool that I will show you also for the next demo, where I can analyze DAX query and try to improve performance and so on. So I can copy the query and run this query from outside of Power BI, or I can run it also in DAX Query View. Remember, I told you one of the views that we have in Power BI Desktop, it's called DAX Query View. That's the one. So if I say run in DAX Query View, it will automatically switch to DAX Query View and execute this DAX code that was generated for me. So in this case, because we have multiple results, it will show me essentially the same thing in a tabular form. So this is the DAX code to populate this particular visual. So this is Performance Analyzer. Performance Analyzer is now available. Previously, it was available exclusively from Power BI Desktop. Since last few months, it's also available from the web user interface. So for all Mac users or all Power BI developers who are creating their solutions from web user interface instead of Power BI Desktop, you can also use Performance Analyzer from there. Once you click stop, it will stop recording all the actions, and then we can turn off Performance Analyzer. The next thing I want to show you is how to optimize your model by changing data types. So for that, I prepared another file which is more realistic, let's say. It contains, it has just one table called fact chat. This is a table. And as you can see, the data is stored on the second level of precision. So we have the information about when the specific chat started. We have date, and we also have time. So how many unique or distinct values we have in this column? We have the entire table. Sorry, I wanted to show you that entire table contains 9.3 million records. Out of these 9.3 million records, 8.8 million distinct values we have for date time. And the example I'm showing you here, this is the example from, this is a real, this happened to me a couple of years ago in the company where I used to work for. This is a real life example. So what we did, we basically loaded data from our source database in Power BI without applying any additional transformations. It was early days for us as Power BI developers. We didn't know these best practices. So what we did, we just pulled columns from the source database into Power BI, and the data in source database was stored obviously on the level of precision of second, right? But this report was created specifically for our customer support department. They were analyzing the number of chats per time per day, like morning, afternoon, and so on. So essentially what they wanted is they don't care if there was 1 or 2 chats within a specific second. They cared about how many chats happened during the day or during the evening, for example. So just to show you the difference and how cardinality of the column impacts the size of the model, let me show you this. So I'll go to external tools and I open this DAX Studio tool that I previously mentioned. It's a free tool. So if you go to daxstudio.org, you can download it for free. It's amazing, but for this demo, I'm particularly using the feature called VertiPack Analyzer, which is a built-in feature in DAX Studio that allows you to connect to your semantic model and see the size and structure of the entire model. You can't do that from Power BI Desktop, at least not yet. So if I go to Advanced tab and click View Metrics, this will return the details about my semantic model. And what is important here? Let's expand our table. Cardinality stands for the number of values. So as you saw, the table has 9.3 million values, and this number looks familiar from Power BI Desktop. We have 8.8 million distinct values in our date TM start UTC column. Now, the total size of this column, of a single column in this table, is 440 megabytes. So all these numbers are in bytes, just to be clear. So this column is 440 megabytes, a single column. What happens if I go back to Power BI and I simply go to Power Query Editor? This is not a rocket science, but let me show you. What happens if I simply change the type of this column from date time to date? So instead of date time, I'll put date. So this will basically create the use case that is completely acceptable for my end user, because they don't care about seconds, hours, and minutes. So I can get rid of it, hit close and apply. Now let's first check how many distinct values will we have now, and then we will check the impact on the overall data model size. We are changing the structure of the table, so Power BI needs to reload the data, but it won't take too long. I'm checking there are no questions while this runs in the background. Okay, this is the number of records. Instead of 8.8 million distinct values, we now have slightly above 1,000. And let's check the impact on our semantic model size. So remember this number, 440 megabytes. If I refresh my metrics, now this column takes 9 megabytes. So we went down from 440 to 9 megabytes. That's like 2% of the original column size, just by changing the data type and still fulfilling the expectation of our end user. So reducing the cardinality of the column is the biggest save that you can make when it comes to data model size. And one of the, let's say, low-hanging fruits when it comes to reducing the cardinality is to use proper data type. In this case, instead of date time, we used date. Similarly, if you take a look at the chat rating column, you can see that it currently shows the data with 5 digits of precision after decimal point. If I switch this to use 2 digits after decimal point, this will additionally reduce the data model size. That's something that you need to take into account. Also, what a lot of people are doing when it comes to reducing the cardinality, but keeping the precision. So I'll go back to Power Query, and I'll revert back to the original solution. So what a lot of people are doing is splitting the column into two columns. So keeping the date information in one column and keeping the time information in another column. So in case that your end users need to analyze data really on a second level of precision, you need to keep this right in your Power BI solution. But what you can do, you can split this into two columns. You will reduce the cardinality. You will reduce the overall data model size, but there is no free lunch. So on the report level, you then need to combine back these two columns again. So you will pay the price by more CPU usage in the measure itself. In the DAX logic, you need to implement this calculation that combines data from both columns then. So just be aware, you don't need to use any of these advanced techniques like splitting column or something like that for small models. Everything that I've shown you here is relevant when dealing with larger models and when you need to optimize performance by either summarization or changing data types. Any questions? You were really quiet today. Okay. Then we'll do the following. We'll take the last break for today, a shorter break, let's say 7 minutes. And after that, we're jumping straight into the hands-on lab. And then it's your turn to work with Power BI. So let's take a 7-minute break, last for today. And then we'll proceed with the lab. Enjoy the break and see you soon. You had enough time to stretch your legs and refresh a little bit before the final run for today. So just a quick pulse check as usual to see what's your current mood. Are you tired? Are you ready to work? To get your hands dirty with Power BI? So I started a pulse check. Quick thumbs up or thumbs down. No thumbs down accepted, of course, but I'm just kidding. If you're tired, that's totally fine. All thumbs up. That's what I like to see. Okay, thanks everyone for confirming this. So, what's next? When we started doing this bootcamp a couple of years ago, at the very beginning, it was just me talking and showing how things are done. There's nothing wrong with that, right? But I think it's a whole different learning experience when you start building things on your own. And that's the best way to learn, and that's the best way to gain experience with the tool itself, by learning by doing, and also making mistakes, facing some challenges, some problems, and then solving them. This is way more impactful than just looking at me doing all these nice demos. So what I prepared, what we are doing since last couple of runs of this bootcamp, is hands-on labs for you. So how this is going to work? First of all, I'll stop pulse check. Thanks everyone for taking your time to respond. So how this is going to work is I'm going to share the instructions for lab number 1 and lab number 2. So the idea is for you to start working on these two labs. We have approximately 40 minutes to complete these two labs for today. But don't stress too much if you don't do that. Because as you will see, labs are accessible. They are stored, hosted on my website, so you can access them whenever you want, even after the bootcamp itself. But you get a chance to work throughout this bootcamp, ask a question if you have any problem, any thing that needs to be clarified or explained better. I'll be here, of course, to try to answer all of your questions. So without further talk, I will share the link for the lab number 1 and lab number 2. And then it's up to you. So whoever completes 2 labs, you have 2 options. You are either free to go, or you can continue working on lab number 3. So it's up to you to decide, but these 2 labs usually take between 30 minutes and 1 hour. So depending on your Power BI skills level, it may take you a little bit shorter or longer, depending how familiar are you with Power BI. So these are the links. I'll also share my screen. So Power BI lab number 1. So I'll share my screen. So what's the idea? Just to give you a brief introduction. So we start with the basics. You will download the data. This is publicly available data, so don't be afraid that you are downloading something that can harm your computer. Not at all. So this is publicly available data from Microsoft's basically GitHub account. Once you download this data, you should extract these files to your local PC. Just memorize where you store them, because you will need to load them later into Power BI. So just memorize location. Is it a downloads folder or something else? And then simply follow the instructions for the lab. There are a lot of screenshots that I hope will help you to understand if you are on the right track or not. But again, in case of any questions, any problems, just let me know, and I'll be here watching out, and I will help you definitely if needed. So let's start working on this, and in approximately 40 minutes, let's see where we are. The first lab is getting data into Power BI Desktop, and second lab is then a little more complicated, but not too complicated. It's transforming data with Power Query. Oh, I see some of you have problems to access the link. Yeah, depending on the... Yeah, maybe there are some restrictions if you're using companies' PCs. Let me see if I can... But I can't share here. I'm not sure if we can share zipped files or not. I can't share directly here in the chat. That's the issue. How about others? Are you able to access the files? Yeah, I see. I'm sorry you can't follow today, but as you said, you can continue working offline using your personal PC. Okay, thanks for confirmation that you can access files. Let me know if you have any questions or issues. Yes, there is a question, will this session be recorded and available for replay? I can then watch the replay using my personal PC and run the lab. Yes, there will be a recording within 24 to 48 hours after the training. You will get the access to recording. So yeah. There is a question, would you please me to lab resources? Sorry, I can't understand the question. Would you please me to lab resources? What exactly do you need? Can you just clarify? Thanks, Andrew. Andrew sent a reminder. Yeah, we are doing these courses on a regular cadence. It's usually once per quarter. I think the next run is in May, but for all of you, if you want to refresh your knowledge in May, I would like to see you again, of course. But we are still at day number 1, so don't leave. How's it going for everyone? Any blockers? Good, I see some thumbs ups. Thank you for confirming. If anyone needs help or some additional clarification, don't hesitate to ask. How's everyone progressing? Anyone done with lab number 1? Or maybe anyone done with already with lab number 2? Maybe that's a better question. There is a question I just started. What hour will we finish today's session? We have approximately 15 to 20 minutes for lab, and then a wrap up before we finish for today. So you have approximately 15-20 minutes more to work on the lab. I mean, live, working on lab during the live bootcamp. Of course, you are very welcome to continue after that if you have time and energy, of course. No problem at all. while you are working, I'll share some additional resources that I consider useful for learning Power BI. So one of those I mentioned is particularly related to learning DAX. So I will share the list of some resources that I consider useful for anyone starting or improving their Power BI skills. And everything that I share, also not everything, but most of the resources that I share are free. For example, some books, of course, they are not free, but all the other resources will be free. So this DAX for beginners, in my opinion, the best possible way to understand the inner working of DAX. This is a playlist on YouTube, around 50 short videos, 5 to 6 minutes, explaining concepts with drawings and like literally very easy to follow and understand. Definitely for advanced DAX, Italians that we already mentioned during this poll. So sqlbi.com. These are just resources for the topics that we covered today. Tomorrow I share for tomorrow's topics. How's it going for everyone? Did anyone complete both labs? Or am I too optimistic with these 40 minutes for these two labs? Almost amazing. Great work. Slowly wrap up day one. For those of you who are almost done or done, I'm curious to hear what was your most challenging part in these labs, or your favorite part or least favorite part. If you can share any feedback about the labs, that would be super cool. I love the lab, summarize everything we saw today. Thanks for the feedback. That's, yeah. I hope yeah, we will talk about DAX. Yes, of course. There will be more DAX, absolutely. And there is a lab specifically dedicated to DAX. Yes, obviously second lab is more challenging, yes, with all these Power Query transformations and data cleaning. But I try to mimic as much as possible the real life. So I don't want you to get a wrong impression about what to expect when you start working with Power BI in reality. Thanks for sharing your thoughts. Thanks. Happy to hear that it helps you as a beginner to navigate the waters of Power BI. What we covered today and what to expect tomorrow. So we started like almost 5 hours ago talking about what Power BI is and what are the tasks of data analysts, what you can expect in your day-to-day work with this tool. Then we covered the biggest part of the exam itself. It's preparing and modeling the data. So we discussed how to bring the data into Power BI, how to connect to various data sources. And once you connect to these data sources, how to clean and shape your data before you serve it to your end users in the form of the Power BI report. Don't forget, and I know this is not the most fanciest part of the data analyst job, to work on the back end, but trust me, in real life, the more time you spend on the back end of your Power BI solution, the more powerful, the more future-proof your Power BI solutions will be. Because building this basis will give you a solid starting point to build your Power BI reports on top of it. So we learned about the Power Query Editor as a built-in tool inside Power BI Desktop that allows us to perform all kinds of different transformations without writing a single line of code. And we also learn how to add new columns, how to create new queries, new tables, append and merge transformations, and so on. Then we discussed star schema and its importance for Power BI. And I can't stress enough how important it is to build a proper semantic model for Power BI reports. Because once you do that in a proper way, you will reap the benefits later when you start writing DAX calculations, building visuals, and so on. So star schema is the way to go. Remember, there are two types of tables: dimension tables, which are descriptive tables, contain attributes about your business processes, and fact tables, which are numeric tables. They contain the information about events or something that happened as a consequence of the business process. Star schema should be your default choice whenever possible in Power BI. Other than that, we also cover some other recommended practices, such as using one-to-many relationships, single filter directions. So whenever possible, try to implement this. We also talked about enhancing data model with DAX calculations. I hope you understood the difference between DAX measures, which are evaluated on demand once the user interacts, once the user use them inside the report visual, and calculated columns, which are pre-calculated and stored in semantic model, calculated on a row-by-row basis. So calculated column, they take the memory space of your model. Measures, they don't take any space, they're calculated on demand. And we wrapped it up by talking about how to optimize model performance, because building a report that just works is nice, but it's even nicer if you build a report that works efficiently. So we introduced some of the techniques, common techniques for optimizing model performance, and discussed tools that we have available out of the box in Power BI Desktop, such as Performance Analyzer, to quickly identify potential bottlenecks in our Power BI solutions. Tomorrow we continue. We are moving slowly to this part that most of learners prefer, and that's building report itself. So learning all these techniques for creating and designing nice looking report pages, visuals, and some advanced data visualization concepts and techniques. We'll also talk about creating and managing Power BI assets, implementing security rules, and so on. Tomorrow we also work on hands-on labs, and tomorrow we play a quiz. So I strongly encourage you to join tomorrow. It's gonna be a lot of fun, a lot of learning again, I hope, and a lot of fun for sure. So with that being said, I'm giving you back 2 minutes of your time. It's not much, but it's still better than nothing. And wish you a nice rest of the day, evening, or night, depending where you are currently located, and looking forward to seeing you tomorrow, same place, same time. Enjoy Power BI and see you tomorrow.
Okay, great. That does conclude today's presentation. Thanks everybody for joining. Last couple things I'd like to add before we do wrap up for the day. A reminder once again that there will be a recording. That recording should post in about 24 to 48 hours. You should get an email notification when it does post, but the recording itself is going to be through your online learning account. So if you need a refresher on any portion of today's presentation, you can always find it there. Also, if you haven't already, we do have a course feedback survey. You can access that through the toolbar at the top of your screen. Any feedback at all you might have, we appreciate it. It just helps us improve these sessions over time. With that, thanks once again for joining. You can log off whenever you're ready, and we hope to see everybody back tomorrow at the same time for day 2. Have a nice day.